the students, we are going to analyze all those things and we are going to start. Okay, fine. Yeah, so this is the first question which we are taken from the data link layer. Okay, the data link layer means what? LAN area, the local area network. So basically, suppose if you are using some LAN protocols, you require reliability as the top criteria, because on the physical layer the channel will be unreliable. But if you are using the data link layer or a LAN which is already a fiber optic cable, so the chance of errors will be less. So you don't require a reliability criteria at that point of time. So the basic idea is, if you want to provide reliability on the unreliable link, on the top of it, using the rules or the protocols, you have to provide the reliability. Say like stop and wait ARQ, go back and ARQ, or a select repeat ARQ protocols, okay, you can apply. So based on that, this particular query is given. So try to analyze this query. It is an important model query. Okay. So if you observe a sliding window ARQ scheme, that is automatic repeat request, the transmitter window size is n, so n is the window size and receiver window size is m. Then the minimum number of distant sequence numbers required to ensure the correct operation of the ARQ scheme. See, basically, so the main idea, so why we take the sequence bits. So the basic idea, so why we are going to take the sequence bits. So with the help of the sequence bits, you are going to get the sequence numbers. So whenever you transmit the message where it is divided into the packets, so when the packets are finally moving in different directions in the internet and they finally reach the destination with the help of the logical address that is given by the source, so those packets has to be distinguished. So for distinguishing the packets, you require a sequence numbers. So for getting the sequence numbers, so in the protocol itself, logically you have to assign the sequence bits. Okay, suppose if you are using a protocol like stop and wait ARQ, so you are going to transmit only one frame. Okay, so if I have taken one bit as the sequence number, so the sender window size will be 1. So sender window size 1 indicates the frames which you transmit in the round trip time, that is you are going to send only one frame in the round trip time. And basically the receiver window size is also going to take it as what? 1. So the receiver window size will be helpful. So whatever the packet or the frame which is reaching to the receiver, that sequence number which is be available in the data, I mean the metadata which is available in the packet or a frame, is going to compare with the receiver window size. For that we require this number. So if it is matching, then only the particular packet or a frame will be accepted. So you can observe here, if I will take the sender window size as some m as a variable, that's what they have mentioned in the question, and the receiver window size as n, or if you just reverse also. So if I add these two numbers like m and n values which are available in those variables, so you can take the window size is what? I mean, if I join these two, I am going to get these two. So basically to design this protocol, whenever you transmit the data, here you take the sequence numbers like 0, 1. Once the sequence number 0, 1 are completed, you are going to again repeat those sequence numbers like this 0, 1, 0, 1 like this. So basically you can see how many distinct sequence numbers you are taking. So 0 and 1 means what? 2 sequence numbers. And if I add the sender window size and receiver window size is also 2. So this gives a clear idea. The number of sequence numbers which are participating will be equal to the sum of the window sizes of sender window size as well as the receiver window size. So it is not only applicable to this stop and wait ARQ. If you want to increase the throughput, you can go for a go back and ARQ. Suppose if I have gone for go back and ARQ. So the condition for the go back and ARQ is what? Sender window size should be less than 2 power m. So only if you take this particular condition, the protocol is going to work, because if I have taken equal to 2 power m, so the protocol is going to fail by a condition called wrap around condition. That means sequence numbers will be repeated, so the protocol is going to fail. So that is the reason you should take less than 2 power m. Suppose say if I have taken m as the sequence bits as 3, then the sender window size based on this condition, this value is 7, and if I have taken that receiver window size as accepting the in order frames, it will be 1. Same like that, if I have taken this is m and this is suppose say n. So here also when I have taken the 3 sequence bits, see if I have taken the 3 sequence bits, so how many sequence numbers are possible? Like 8 sequence numbers like 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, so on like this. So the window is taken from 0 to 6 because it is total count value 7 is the window size. But have you observed here one important criteria? So the number of sequence numbers which are participated here, you can say 0 to 7, these are the distinct sequence numbers you can say, or you can say 8 is the sequence numbers, distinct sequence numbers. So what is the sender window size? It is m, receiver window size it is n, so it is m plus n. So basic idea, whether you go for any ARQ protocol, it might be a stop and wait ARQ or a go back and ARQ or further selective repeat ARQ also, this condition will always holds good. So based on that, Srinivas, good afternoon. Yes, very good. Same like that. If you want, you can go for the selective repeat ARQ also. There also, if I have gone for the selective repeat ARQ, so the condition for selective repeat ARQ will be like sender window size will be less than or equal to 2 power m minus 1. This is the condition where m is the number of sequence bits. Just like in go back and ARQ, the protocol will be successful only at less than 2 power m, otherwise the protocol is going to fail. Same like that here also. But here in the selective repeat ARQ, the receiver window size will be less than or equal to 2 power m minus 1. So basically when m I have taken as 3, just like here in the go back and ARQ. So if you observe here in the case of the selective repeat ARQ, the sender window size will be how much? It will be 4. If you substitute in this expression, you are going to get 4. See, less than equal to 2 power 3 minus 1, less than or equal to 4. So maximum I can take it as 4. So that is how the sender window size is what? 4. Same like that here the receiver window size, we are taking this condition only, and you can observe both in stop and wait ARQ and go back and ARQ, receiver window size is 1 because there it is accepting the in order frames. But here it is going to accept the out of order frames also, because in the internet or in the LAN, when the packets or frames traveling in different paths, they may come at a out of order. If you want to design a protocol where these out of order packets has to be accepted, at the receiver side the window size should not be 1, it will be more than 1. Just like here we have taken as what, less than or equal to. So then this value will be something like it is 4. So here also you can take it is m and suppose say it is n, okay, or these are just variables na. So if I add m plus n, so this value is going to be 8, but here you see m you have taken as 3, so m is equal to 3 means how many sequence numbers? 0, 1, 2, 3, 4, 5, 6 and 7. Distinct sequence numbers are what? 7. So the sequence number counts will be equal to sender window size plus receiver window size. It is matching with all the protocols. Okay. Yes, Srin was correct. It is m plus n. So for this particular problem, what is the answer? It is m plus n. That means this is the answer. C is the answer for this. So sometimes they can ask a question in this way directly with the variables also they can ask. So the answer is what? M plus n. Yes, Yashwant, good afternoon. Srinivas, good afternoon. Yeah, this question is regarding what? The data link layer. So it's not like always the frequently asked questions, IP addressing, subnetting and supernetting. So they can ask in any topic in any way. Okay, so this is one of the important topic in the data link layer regarding the flow control policies. Okay, I hope everybody has done. So you can go for this second question. Yeah, basically the second question also regarding the data link layer, but the concept is, see, when we say that the links are unreliable or in the internet WAN area is unreliable and these packets are traveling different paths, so there is a chance that the packet can lost. So the basic idea is when the packet is lost in the network, this gives a clear idea this packet is not reached to destination. So if it is not reached to destination, the receiver can't send the acknowledgement. Then this acknowledgement cannot come to the sender. Then sender का जो timer होता है, the timer whatever it is there, it is going to expire. So once it is expired, then again it has to resend. That means the protocol should have a provision of resending the data when some packets are lost in the network. So based on that, here the probability is involved in this question. So that means probability means something like on average the system how many times the packet or the frames has to be retransmitted such that there will be a successful way of receiving that packet or the frame you can say. See, normally when we use a word like a mean or average in mathematics, so when you number of terms are fixed, you just add them, divide by the number of terms. But especially when you apply the real time such like this probability where you don't know the success rate because you are designing a protocol called reliability, then when they ask a mean here the meaning of mean is somewhat quite different from the general mean. So here the meaning of mean is on average how many times you transmit the same frame or a packet again and again such that it is able to receive the destination. So I have given the hint for this problem, so please try. Yeah, good afternoon Srinivas, Yashwant, Jimmy, good afternoon everybody. So you would like to give some, shall I give some information about this question? You see, on a wireless link. So basically what is the wireless link means what? A unguided media. Some examples like a transmitter is ground station is transmitting the data in the form of signals in a wireless mode where that signal is able to reach to a satellite. So that comes under a unguided media. So how can you expect that signal, whatever it is reaching to satellite, is always a line of sight? Line of sight means it is going in a straight path. So there will be obstacles like roads, vehicles. So these, they are going to divert and again converge to the receiver, you can say. So these signals which are diverging and again reaching to destination, they may actually increase the amplitude of this line of sight signal, or may decrease, or there might be a change of phase also. But to make it a reliable, okay, finally the signal has to be captured by that particular receiver. For that, that particular receiver, it might be a satellite or a device, should have a capability of actually receiving that signal. Okay. So based on that, this question I have given a hint. See, the probability of packet error is 0.2. That means the loss of that signal is, or a data is 0.2, you can say. Or we can say the success rate of that signal or a data to reach to receiver is 0.8, because total probability is 1. So when they have mentioned that error probability is 0.2, probability of safely receiving is 0.8. So that is the further meaning of that question. Yes, it is a flow control. Harish, correct. Ram Kumar Sir. Okay. See, they have mentioned that a stop and wait protocol is used to transfer data across the link. So they use a word like across the link, means inside that cable or a link you are transmitting the data. Sir, they have already mentioned a wireless link. So how do you say it is transmitting across the link? See, basically there the data or the signal is transmitted in the form of electromagnetic waves. Normally in the case of the radio waves, they will be transmitted. Okay. Yeah, if you want further, you can read and analyze this question. See, the channel condition is assumed to be independent from transmission to transmission. So the basic idea is, so from transmission to transmission means the power capacities are changing, the signal amplitudes might be changing. So they are telling that these are independent parameters. That is the meaning of this question. So now you can see what is the average means. Average means what? Mean. Number of transmission attempts required to transfer 100 packets. So basically why they have mentioned 100 packets, you can send a complete message now. See, the reality is in the internet or any LAN, the intermediate devices like the antennas or these devices like routers or the switches, they have to process your data. If you send a complete message, so if the message size is very high, so these routers or devices or any antennas, to process them, it becomes very difficult. So they have to process the content very fastly, so that we have to make a protocol where the packet size should, where the actual content should be small. So that is the basic reason they are sending the complete message by dividing them into packets. So in this problem, that message is divided into 100 packets actually. So I have given the complete idea of the question, so you can try. Yeah, see, this is the basic idea I have mentioned. So the logic is like this. See, the probability of packet error. So I can write like this. See, the probability of data or a frame, what probability of a packet, okay, that is lost. Is lost. Suppose say if it is mentioned as what? P. It's P. Okay, then the mean number of transmissions means on average, mean number of or mean of transmissions, you can say on average number of transmissions. Number of transmissions. So for this the derivation value will be 1 by 1 minus p. So this will be available in the class notes. You can check that 1 by 1 minus p. That means when you say whether it's a wired communication or a wireless, when you say the link is having a unreliability, on average how many times you transmit a single frame such that you get a success will be 1 by 1 minus p, when p is the probability that is lost. So it is for one frame. But here you see they are asking for the 100 frames, 100 packets, you can 100 packets. So basically in the network layer you call them as packets, in the data link layer you can call them as what? The frames. Yes, Sagar Kumar, very good, correct. Jimmy, correct. So this gives a clear idea. So for this is for one frame. So this probability is for what? One frame. Yeah, then for n number of frames, that means n number of packets. So this value will be how much? N by 1 minus p. Sagar Kumar, very good, correct. Babu, correct. Varun, yes. So here n is nothing but what? 100 packets. So this I can written as what? 100 packets divided by 1 minus. So what is the probability of packet error is how much? 0.2. Or if I do the calculations, this value will be 100 by 0.8, or I can, that is 5 by 4 into 100. So 425, so 5 into 25, so this value is what? 125. So from the given options it is available here. So B is the answer. So the basic idea is, if the question has given precisely about a transmitter and the receiver called satellite, so directly you can solve it like this. So in some questions when you are solving, they just mention 2 ground stations via satellite, or sometimes they mention only ground station to a satellite, or they can, if when they have mentioned like that, so there should be a clear idea whether it is a ground to ground station or ground to satellite station also. If they have given clearly, you are able to answer the question in a precise manner with the fundamentals of the mathematics and the knowledge whatever you had it. Okay. So here the answer is what? 125. So the basic idea is, for sending those 100 packets, you have to send 125 is the answer. Yes, Sagar, correct. Yes, good. Everybody has done this answer correctly. Yeah, this also comes under the data link layer on the, in the LAN, whether it is a reliable or a unreliable link. On the top of it, with the protocols, you are providing the reliability. Okay. I hope everybody has done. Yeah, 125 packets. Yeah, you can go for this third question. So this also we have taken from the data link layer. So read every word in it, you will get a complete idea when how to approach the problem. Yes, Jimmy, correct. Yashwant, correct. So they are just telling that the station A uses a packet size of 32 bytes to transmit messages to station B. So basically here the idea is, even you transmit a message, that should be divided into the packets, where the each packet size they have given a generic number like 32 bytes using a sliding window protocol. So the basic idea of what is the purpose of the sliding window protocol, as you divide a message into the packets. So for every individual packet you are going to assign the sequence numbers. So that sequence numbers you can get from a logical window called sliding window. So you should not send a same sequence number now, like for first packet it will be 0, for second packet it is 1. So for that you require a window actually. Fine. You can see the round trip time between A and B is 80 milliseconds. So the basic idea why they have given a round trip time, see the only way the content or a packet whatever you transmit, it will be knowing that that packet has received safely with the help of the acknowledgement. So basically the journey where the packet is starting and reaching to the destination is a PT, propagation time, and once from the receiver side coming back to the sender side one more PT, PT is the propagation time, length upon velocity. So PT plus PT is a round trip time. So why you have to consider this round trip time? So the only way the sender knows that your data packet has received safely with the help of acknowledgement. So that's what they have given a round trip time of value. How much it is? 80 milliseconds. And you can see the bottleneck bandwidth on the path is 128 kilobits per second. So basically the bandwidth is the capacity of the link. They have mentioned bottleneck bandwidth. What's the meaning of it? Generally, if you take in a internet area where you are transmitting the data packets or a message from a very longer distance, so you will find a variable bandwidth in between, because some packets in the starting journey they go via a guided media like a fiber optic cable. So next you may get some terrain area, as a hill station. You can't have a cable laying on the hill station. The only way is the packets has to go in a wireless mode via antenna. So this gives a clear idea the terrain is not flat in the entire journey, you can say. So this gives a clear idea that on the direct link, okay, the terrain, the land, the bandwidth will be somewhat different from the bandwidth of the wireless, and after some time maybe you may get the area of the water or a ocean area, so where the signals has to go only inside the ocean, the cables lay down. So since that the land is not, and I mean the entire terrain is not a single flat structure, the bandwidths can be variable. So the common sense is telling that the data has to reach from end to end. Out of all the bandwidths of all the links, whichever is the minimum should be considered, that comes under the bottleneck bandwidth actually. So why you have to consider that minimum only? Because out of all the minimum if you would consider, this content will safely go to the destination. So that is the meaning of the bottleneck bandwidth actually. Yes, Sagar, correct. Anushka Srivastava, very good, good. 40 is the answer, correct. Good. So you can observe, we can write like this, say a round trip time, okay, it is given as 80 okay, milliseconds, and the bandwidth of the bottleneck bandwidth is given as 128 okay, kilobits per second. So this bandwidth I can write by separating the terms of the numerator and the denominator. I can write in 1 second, it is 128 kilo means what? 10 power 3 bits. So this is the information they are giving in terms of the bandwidth, but we are taking a round trip time. So why we are taking the round trip time? Because based on the acknowledgement only you can transmit the data. So round trip time is given as 80 okay, milliseconds. So in this 80 milliseconds, how many bits you can transmit? So 80 into milli means what? 10 power minus 3 into 128 into 10 power 3. So these many bits you can transmit actually. So this 10 power minus 3, 10 power 3 will cancel. So 80 into 128, these many bits you can transmit in the round trip time. But here we want to find out the window size, that means how many packets or the number of frames which you can transmit in a round trip time. So these are the total bits if you are transmitting divided by the packet size that is given is 32 bytes. So 32 into 8 because it is given bytes na. So like this. So basically why you have to divide that the packet size? Just now I have told you the mediating devices like the switches or the routers, they have to process the packets in a faster way. The processing time will be less when the packet size is small. Otherwise, if you just send a complete message of this 80 into 128, it will go, no doubt it will go, but the mediating devices processing them, it takes so much amount of time. So the basic idea is, if this bigger size of that message, whatever you transmit, if you divide by that packet size, you will get a number of packets, and these packets are frames, they can scattered in different paths, because internet is a very big different networks will be there, and finally they will be joining to destination with the help of the sequence number. So that is basically when you are solving here, sometimes you forget this 8 value actually, because they have given the bytes now. So that is the idea. I think Yashwant is asking, sir, is optimum window is same as throughput? No, see, you ask a good question. See the Yashwant, I think. See the optimal window size. The window size is giving you an idea how many the packets or the frames which you transmit in the given time. Here it is a round trip time. I think Yashwant Ray is asking. But throughput is something like whatever you transmit, how can you say that all these packets will definitely go to the destination, because they are scattered, they are moving in different paths. So some packets can lost in the network, because when they travel different paths, since they are traveling in different terrains, so normally the loss of the packets will be very high in the wireless communication. Some packets can be lost. So the successful receiving packets at the destination, it is called it as the throughput. I think Yashwant is asking that question. I hope you understand the meaning of the window size and the throughput now. The throughput is whatever the rate which you transmit, or whatever the packets which you transmit in a given time by that sender, it is just the data rate of the sender. But throughput is quite different. The whatever the complete message you transmit them as packets, the successfully receiving packets at the destination is called it as the throughput. Okay. Yashwant Ray, have you understand now? And you see, now you can ask, I think one more person is asking, sir, what happening to the packets which are lost in the network because they are unreliable now? Obviously, the timer is going to expire at the sender side for the missing packets. So obviously you are going to retransmit now. So these retransmissions will be, the packets will go to destination, and these packets again will form a queue at the receiver with the help of the out of order packets which are waiting at the receiver side. So again they are going to be joined. So or we can say a query like the successfully receiving and successfully retransmitted packets combinedly, you can call it as the throughput, you can say. Hope now you understand, Yashwant, no? I think you asked that question. Yeah, it's a very good question, because when the internet is unreliable and some packets are lost, obviously the transmissions plus retransmissions combinedly, you got a successfully receiving the data. Or if you say, no sir, at the receiver side, if the remaining packets are not waiting, because that is how the protocol is designed, just like every datagram will travel independently in the UDP, that is also okay, because normally where the UDP is going to support, every datagram is going to travel independently. There you don't bother about the retransmissions. But especially some protocols like TCP, these all the segments, they are going to wait at the receiver TCP before giving to the application layer. So they are waiting for the retransmitting or the missing segments actually. I hope now you understand completely, Yashwant. Okay, yeah. So if you calculate, this value will be how much? It is 4 and it is 10. So 10 into 4, it is what? The 40. So we can say the answer is what? 40. Yes, Srinivas, Sagar, Babu, okay, very good, excellent, everybody has done correctly. So you can, I hope now you can go for the next question. Yeah, so you try to analyze this particular question. Yes, Ayush Birari, very good, correct, 40. Birari, correct, Ayush, correct, 40. Please try this question also. Yeah, shall I give the hint for this particular question? See, consider two hosts. See, basically what is the host? The website or the content which is hosted on a physical hardware device like the computers. So you can call them as host. Like a HTTP service you might be hosted on, or a SMTP server or a FTP server. So normally the host means, the generic word is the end devices, you can say, end devices you can say. Connected by a single direct link of rate 10 power 6 bits per second. That means they have given the bandwidth of 10 power 6 bits per second. So the distance between these two hosts, they are given as 10,000 kilometers. Okay, the length we can say, the propagation speed of the link is 2 into 10 power 8 meters per second. Okay, the velocity of the medium, normally for a data transmission you don't have any the velocity will be guided by the medium. You might be learning in a properties of a light in physics. So light travels in a straight line, the medium of that is going to change, the velocity is going to change when it's moving from medium to medium. But normally the data won't have any velocity, it is guided by that particular medium, you can say. Okay, the host X sends a file of 50,000 bytes as one large file. See here the question, the message is not divided into packets, directly the message is transmitted. So if you do these calculations, so we can say the transmission time is nothing but the data size, that is the message size is given as 50,000 bytes of the data divided by the given bandwidth is how much it is, 10 power 6 bits per second. This is the rate at which you transmit. So basically the data rate or the width means what? When the width is more, frequency is more, you can send more signals, more bits in less amount of time. So basically when the denominator is high, overall value will be less, time will be less, so data will go fastly, you can say. So if you do these calculations, you can see they are asking in the milliseconds. So you keep 10 power 3 below, so cancel this okay, these 3 bits, if you cancel 3 bits, you can have 10 power 3. So you can represent in the milliseconds, and these bytes convert into 8 bits because these bits will cancel with the denominator. So 50 into 8, this value is 14. This 10 power 3 goes to top, so this is going to become milliseconds. So transmission time is what? 50, or sorry, how much it is? 400 milliseconds, you can say. So, and after that you can calculate what? The propagation time, because they are asking the transmission time and the propagation time. Propagation time doesn't depend on the content, whatever you transmit, it only depends on the length that is given and on the velocity. So you can say that length is given as how much, you can see in this particular problem, it is given as 10,000 kilometers. So this is 10,000 kilometers means what? Into 10 power 3 upon the velocity is 2 into 10 power 8. So if you do these calculations, so they are asking in the milliseconds now. So this value is how much? 10 power 3 will be cancelled. So this is 5,000 into into 10 power minus 5. So seconds, you can say they want to represent in the milliseconds. So obviously it is 50 milliseconds. So check your answers. So transmission time you got it is 400 and propagation time you got it is 50. So this is available at option D. So D is the answer for this question. It's a direct question, you can see. How many people has done? Let us check. Yes, Yashwant, correct. Anushka, very good. Srinivas, correct. Sagar, good, very good. Prakash, correct. D is the answer. Yeah, sometimes it will be a direct question, but they want to test only the calculations. You can see it's a single direct link, you can see. I hope everybody has done. So I am switching to the next question, you can say. Yeah, so if you observe this particular question, see the question is so clear and precisely they have mentioned. Okay, so what they have mentioned, a ground station to the satellite, you can say, or I mean, so to say that suppose if I have taken, okay, suppose if I assume that this is, okay, some the ground, okay, the ground area, and this is some antenna, and this is the actual receiver point where it is able to receive the signal, and I assume that this is the ground satellite or a ground station, you can say. Normally a dish will be connected, so here also in a 3-dimensional, okay, the stations will be there. So you can say this, you can call it as from here you are transmitting the signal. So whatever you transmit in this free space, so the time at which it is transmitting, so you can call it as the transmission time. So this is where the signal is transmitting. So I can call this is the ground station, and this is the antenna or the receiving station or a satellite antenna station, you can say, or the receiver, you can say. So you are transmitting in the free space via the radio waves. Suppose if the signal is moving, okay, straight way, then you can call it as this is called line of sight, okay, LOS, or if it is okay, the signal is connected to some obstacle like a tree or some vehicle and it is going, means what, it is an indirect ray, you can say. This is called as a line of sight. So basically for placing that signal or a content on the channel, you can call it as transmission time, and the content whatever it is receiving, this you can call it as the propagation time. So this is the hint of this problem. So now you read this question. I have given the hint. Yeah, see, this is the bandwidth of the link, 100 megabits per second link between an earth station. So this is call it as the okay, the earth station or a ground station, you can say. And a satellite, see, that is given at a satellite or that particular antenna at an altitude, at what height that particular satellite or the receiver is at, 2100 kilometers. So the signal propagates at a speed they have mentioned. So first to calculate the transmission time at which it is going to transmit the signal. So how it is going to transmit? So the data size, how much you want to transmit? See, the time taken in milliseconds, here also they are asking milliseconds, rounded off to 2 decimal places for the receiver to completely receive a packet size. So what is the packet size? They have mentioned it is 1000 bytes. So try to convert into bits. So into 8 bits, you can say. So this is the data size upon bandwidth. So what is the bandwidth of the link that is given? The resource, or you can say what you can say that the particular okay, the system. Normally we say that LTA system, you can say that LTA system is providing you the bandwidth of 100 megabits per second. So we can write this value as 10 power 8 bits per second. So in this given or can say that h of t or the given bandwidth, this is the data which you transmit, you can say. So since they are asking in the milliseconds, so try to convert into the milliseconds. So bits and bits will cancel. So this is nothing but how much you are going to get. This is 8000. Okay, the bandwidth is 10 power 8. So this is nothing but how much, 8 into 10 power minus 6 seconds. But since they are asking in the milliseconds, so try to convert into milliseconds. Okay. So, if you convert this, I create as 0.008, then it becomes 10 power minus 3. So, 0.008 milliseconds. Or you can say for the ground station to transmit its data or a signal on that channel, I mean that particular medium, that is a wireless medium or whatever the medium you are providing, it is taking a time of 0.008 milliseconds. Okay. Then after transmission time, the signal has to propagate. So, you can see here in this diagram, after placing that, the signal has to propagate. So, that time is can call it as the P of t. Simply we can say the signal whatever you transmit. So, here you can call that signal as x of t, and here the signal once it is received, it will not be x of t, it will be some y of t, because some delay is there now like tt and pt, and there will be some shift also will be there, because the signals can be diverted and it can go like this. And here the medium whatever it is providing this, you can call it as the h of t also you can say. Okay, or we can say this y of t is nothing but what, x of t into h of t. So, transmission time already you have completed. So, here you require what, the propagation time you can say, propagation time. Yeah, so calculate now the propagation time pt. The propagation of the signal depends on the length and the velocity. So, how much is the length that is given as the satellite is at a height of 2100 kilometers. So, this is 2100 meters means what, into 10 power 3 units are meters, upon the velocity is given as 3 into 10 power 8 meters per second. So, try to convert in the milliseconds, because they are asking in the milliseconds. Okay, like that. Achha, here you are getting 10 power, okay, 3 means, okay, it is going to become 5, then this value becomes how much? Yeah, 0.08, correct, 0.08 milliseconds, okay. So, this is the transmission time. Yeah, calculate the propagation time. Yeah, transmission time how much you are going to get? 0.08 milliseconds, yes. Because it is 3, na? 10 power 3 minus 8 means 10 power minus 5. So, 10 power minus 5 means 0.08. Calculate the propagation time. Yes, Sagar, correct. This value is how much? It is 7. 7 milliseconds, good. 7 milliseconds. So, here we can say for transmitting this particular signal, how much it is taking? 0.08 milliseconds, okay. And this signal to propagate, it is taken how much? 7 milliseconds. So, basically this y of t, whatever the receiver is receiving this signal, in how much time? A delay of t minus t naught means around something like this value is 7.08 milliseconds. The signal is receiving the satellite, which is at a height of 2100 kilometers. Yes, Sagar, correct. Prakash Baba, 7.08, good, very good. Final answer is what? 7.08. So, why here only one side the transmission, only TT and PT is considered? Because the satellite has received the signal, where the satellite is giving back the acknowledgement to its ground station by processing the data, or it is sending signal to some other ground station and giving back to the station. They are not asking all these things, they are just simply asking how much time the signal is reaching the satellite. That is what they are asking. I think some students are asking like, sir, why on the other side transmission is not considered? You can see the question. See the time taken for the receiver to completely receive a packet of what? 1000 bytes transmitted by the sender. That's all. Only one side journey only they have asked. So if the question is precise, you can give the complete and clear answer like this. So what is the answer? 7.08 milliseconds. Yes, Anushka, correct, 7.08 milliseconds. Good. Yeah, so here you can go for, so far the 5 questions whatever so far we have covered. If you observe all the questions normally related to the data link layer, the flow control, how you are going to provide a reliability, if the data is lost, how probability is involved in it. So those questions we have solved, and now here you see this is a correcting code we are trying to analyze. So the hint for this particular question is something like to correct D errors, the minimum Hamming distance is 2D plus 1. It is not a detection, it is a correction. You can say they are asking for the correction. So 2D plus 1 is D plus D plus D plus 1. 1D plus 1 is for detection. After detecting, once you get a invalid code word, from the invalid code word you have to retrieve unique valid code word. So to retrieve that you require one more distance of D. So that's why it is 2D plus 1. So the hint is first to calculate the Hamming distance between the given code words. Hamming distance is something like between the existing code words, existing valid code words, you have to find out the number of bits that differ each other. Okay, please try. Yes, Jimmy, correct. Sagar, correct. Yes, Yashwant, correct, correct. Yashwant Ray, correct. Using XOR in the question we can get easily, yes, correct. Babu, you are telling that it is 3. No, no, see, it is not a detection, it is they are asking for the correction. Yes, Varun Kumar, yes, very good. It is what? C is the answer, okay. So how to find? It's very simple. You take a code word like this, okay, 4 zeros, and the next code word is what? 4 zeros and 4 ones. Next code word is 0 1 0 1 0 1 0 1. So just I am writing the code words that are given in the problem. So it is 1 0. Okay, so 1 0 1 0 1 0, and here it is the 4 ones followed by 4 zeros. So that is the code words. So first to find out the Hamming distance. So basically the meaning is whatever the circuits you are designing at a sender computer and the receiver computer or the devices only in the data link layer, these devices should have the error capability mechanisms also. So whatever it is receiving the content, whether it is a CRC or parity or checksum, whatever you are getting that content, okay, whether it is a detecting or correcting code, they are going to have the set of codes actually. So first to calculate the Hamming distance. Remember, Hamming code is different, Hamming distance is different. Hamming code is a correcting code. Hamming distance is the number of bits that differ each other between the code words actually. Okay. Kundan, it's live. It is a live session going on. Kundan Kumar, it is a live session. Simplified TV, Ayush, correct. So if you calculate, you can see that the Hamming distance is 4. Hamming distance is 4. So what is Hamming distance? See the codes, see these both are same, these both are same, these both are same, these both are same. But this is different, this is different, this is different. So how many bits are differing? Say 4 bits are different. So this 4 is the Hamming distance, you can see. Same like that, between these two you calculate the Hamming distance. Because they have given all the set of codes. Okay. You can see 1, 2, okay, like that it is 3, then it is 4. So here the Hamming distance is what? 4, like this. Kundan, it is a live session going on. Yeah, you can say between these two also. You can say differ, differ, differ. Here also differing, differing, different, differ. So here the Hamming distance is here. So out of all the Hamming distances, the minimum Hamming distance you have to consider. Why minimum? Because if you take the minimum Hamming distance between every two code words, the minimum Hamming distance is going to satisfy all the code words, you can say. Okay, like that. If you take a minimum Hamming distance, the correction is at first detection and then correction is going to be possible actually. Same like that between these two, if you observe, see, differ, 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 differ. How much it is? 4 is the Hamming distance, like this. Yes, Anushka, correct. Same like this, between these two you find it, between these two. So you can see it is 4. Okay, so same like this, between these two you can calculate. So 1, okay, differ, like this, it is 4. So anyway, so here you got calculated all the Hamming distances, you got Hamming distance as how much? It is 4. So now you apply in that formula. Remember that it is, they are asking correction. See, you observe this word, they are not asking detection, correction they are asking. So after you got a invalid code word at the receiver side, this invalid code word which is modified by the noise, but actually you transmitted the valid code word. From the invalid code word, the receiver has to find out unique valid code word. For that, it has to eliminate remaining n-1 valid code words. Precisely it has to find out, then that is called as a correction. For detection it will be d plus 1, for correction you require one more d, so it is 2d plus 1. So you can calculate. So 2d plus 1, here it is how much? It is 4. This d is the Hamming distance. So this is the formula for correcting d errors actually. So d errors can be corrected. Okay, like it is not a detection. See, if they ask for a detection, apply only d plus 1. Apply only d plus 1. It is for a correction. So this we can written as 2d is equal to 3. So d is nothing but 3 by 2, or this is 1.5, or d is equal to 1. Here after solving the entire question, say 1.5, so why can't you make it as a 2, because you got 1.5 now. So here the point is, especially for a correcting code, either you can get a completely correction or not correction. There won't be any half correction, half incorrection. You can't apply probabilities. So here 1.0, 1.1, so on up to 1.5, 1.6, so on up to 1.9, all are treated as 1 only. Like 2.0, 2.1 up to 2.9, you are treated as 2. You can't apply in the any C language or some other language, like if I get 1.5 above, I will make it as 2, or 1.5 below, I will make it as a 1. The floor and ceiling concept you can't apply here actually. So we can say here it is, what is the answer? So it is 1. So C is the answer for this question. Yes, Anushka, correct. Varun, very good. Ayush, correct. Yeah, everybody has done this question. Yeah, you can go for the next question. So basically, to solve this question, you should know aware of all the layers, their functionalities, what metadata should be added, what functionalities are required. Basically, see, the basic idea is, especially for the routers, this mediating devices, the basic idea is they have to process the data packets, they have to forward on the best immediate path using the routing algorithms, and they have to form autonomous systems for finding the best route. They have to provide a traffic shaping. So these are the functionalities of the network layer, so-called a routing. And if you observe, a data link layer functionality is not like end to end. It is only in a small area, like immediate router to router, or in a small LAN area. You have to provide some functionalities like converting a packet into small frames, so that errors can be detected easily. okay, to provide only the flow control, or you want to provide a reliability on the unreliable link only on a small area. And the transport layer functionalities is like end to end. Even the complete message, whatever you transmit, if they divide them as packets, these packets will be processed by the routers, and all these packets will come to the destination node. There at the transport layer, so called the TCP, they have to provide a end to end okay, the functionality, something like joining again all these packets to get a complete message with the help of some sequence numbers at the TCP at the transport layer. So these are the functionalities you should aware of it. So this is the idea I have given, so you can approach this problem. Yeah, please try this question. Yes, Jimmy, it is correct. You can see the network layer functionality is a routing, you can say. Network layer functionality, main function is what? A routing only with the help of these mediating devices like this router. Router is a multi-interface device where multiple interface will be there, but only on one interface the packet has to be forwarded by a router by performing bitwise, and with a mask it is going to forward by comparing with the prefix matching, then it is packet will be forward on the best path, you can say. So that A is correct. And if you go for option B, you can see data link layer bit synchronization. So here is the problem. Data link layer, normally they provide a frame synchronization. What should be the size of frame? For example, you see if you go for a bus topology, which is a Ethernet, they provide a MTU value of 15-18 bytes only. Suppose if you go for some other HDLC or some wireless, there the MTU, the size of the frame is changing. So basically the unit called frame is going to change from LAN to LAN. So they provide a frame synchronization by adding some extra bits like preamble, SFD, flag bits like that. So they provide a frame synchronization, it's not a bit synchronization. So that is a mistake. You can see option C, transport layer is end-to-end process communication. So this is correct only. So how it is going to provide end-to-end process communication? Because at a transport layer, it is going to provide the port number. So with the help of that, so it is going to provide end-to-end not only with the port number but also with a sequence number. Say like if you go for a TCP, they provide a sequence numbers and the ACK, okay, and with a source port and the destination port. UDP also provides source port and the destination port. So we can see that is also correct. So option D, medium access control, sublayer and a channel sharing. Yeah, this is also correct now. So what is the basic idea of this medium access layer? See, normally if you go for a bus topology where many systems are connected in that data link layer or this cable, so they want to share that particular cable. So during that sharing, you have to apply some protocols so that the throughput can be increased, where the loss of data can be less. So by applying some protocols like pure Aloha, slotted Aloha, CSMA, CSMA CD, where you can apply some Poisson distribution, because there the channel is a non-deterministic. So in such cases, you can apply the Poisson distribution, because the arrival of how the packets will be transmitted by different stations will be at what time they are going to transmit, we doesn't know. So there the channel sharing is going to happen, which you can do with the help of the protocols. If you go for the wired communication, you can go for CSMA by CD, or if it is a wireless, you can apply CSMA by CA. So this is the entire analysis, but now they are asking the incorrect statement. So B is incorrect, so you put a tick mark for it. So B is the answer for this question. Hope everybody has understand this one. Yes, okay. So that's what theory questions also we are involved in it. So the easy way of solving the theory questions is in this way, along with the numericals. Once you understand the concept end to end at every layer, all theory questions and the problems also you can easily solve how the things are happening. Okay, like next, everybody has done it, so we go for next question. Yeah, please try to solve. So this question is regarding what? The Hamming code word actually. See, this is the Hamming code word, you can say. Yes, Sagar Kumar, correct, very good. Akash Chaudhary, good, correct. B is the answer. Jimmy, correct, good. So, what are the things they have mentioned? You can see, read every word in it, you can easily get the answer. See, assume that a 12-bit Hamming code word consisting of 8-bit data and 4 check bits they have mentioned. So, you can see 8 plus 4, how much it is? It is 12 bits they have mentioned. So, this is the codes you can see. So, the rules of the Hamming code is what? For the data, you are going to add some extra bits called parity bits, and the number of parity bits which you add will be given by a relation 2 power r greater than or equal to m plus r plus 1, where r is the parity bits, m is the message bits. What is the second rule? The parity bits should be available or should be placed in the power of 2 positions. So, that is what they have given, and they are asking that x and y values. Okay. So, the given you can see D1, D2, D3, D4, D5, D6, D7, D8 means 8 bits they have given, and the check bits you see C1, C2, C4, C8. Here they use some variable like y, which is a bit, either it is a 0 or 1, and here it is a D5, x is a bit 0 or 1, that you have to find out. Okay, understand? So, calculate. Yeah, you have to go for the even parity. Okay, the rule of the Hamming code is what? The even parity in the total number of ones in the complete code, you are going to get even parity. Okay. You can see here I have taken C1, C2, C4, C8 is 0, 1, 0, y. You can see here it is mentioned na. See 0, 1, 0, y. I have just written reversely because I want to write P1, P2, P4, P8. 0, 1, 0, y. Same like that D1, D2, D3, D4, D5, D. If reversely, if I write 1, 0, 1, 0, x 0, okay, 1, 1. So, that is what here it is written. You can see 1, 0, 1, 0, x 0, 1, 1. So, basically this value either is 1 or 0 they are asking, which is at D5, and here also the parity P8 y they are asking. So, as per the rules of the Hamming code, the parity bits should be placed in the power of 2 positions. So, here you see I have written, you can see. Totally why you got 12 bits? Because the data bits are 8, parity bits are 4. So, 8 plus 4 totally 12 bits. So, that is what here I have written, you can see. And what is your observation? This C1, C2 and C4 and C8, you can C1, C2, C4, C8 are there na. So, these bits you have placed in the power of 2 positions. You can see 2 power 0 you have placed a 0, okay. 2 power 1 you placed a 1, and C4 is 2 power 4, 2 power 2 means what? For 0, 2 power 8 y you placed, in between the given data you have placed. After that, here you have to calculate what? The parity bits, you can see. So, how to find a parity bit? It is very simple. See, suffix value is 1. When suffix is 1, take one number, leave one number. See, you have taken 1, left 3, left 2, taken 2, left 4, taken 5, like this. So, after taking all these values, here you got a x. So, x you have to find out. So, total number of ones should be even as per the rules of even parity. So, you tell me what value I have to place here, so that I will get the total number of ones as even. See, if I place x as 0, so total number of ones will be 1 and 1 is 2, 2 is even, so x value becomes 0. So, that is how you got a variable called x value as what? 0. Yes, Prakash, correct, very good. Varun, correct. Sagar, very good, correct. Good, very good. Okay, that is how you got. Yeah, same like that. Now, when you calculating this P2 or P4, when you calculate here, we don't have any value like x and y to calculate. They are asking x and y. See, now you see you need a value called y, which is at a position 8. So, I want P8. So how to get a P8? You know very well. So suffix is 8. So take 8 numbers, leave 8 numbers. You have taken 8, 9, 10, 11, 12. You stopped at 12 because you don't have the 12 numbers. So in that process already x you got 0, you have substituted, and here y at a position called y. So 0, 0, 1, 1 is there. So how much value I have to place for a y so that it is going to follow the even parity. So if I place here 0, 0, 0, 1, 1. So 1, 1 means what? 2 is even. So y is going to become 0. So what is the final answer which you got? X is equal to 0 and y is equal to 0. Okay, like that. So this is the answer for this question. See, like in actual any question, if this D4 or D3 is again repeated, you have to understand that is going to tell you the common sense once you know the rules how it is going to apply. So for this, what is the answer? X is equal to 0, y is equal to 0. So A is the answer for this particular question. You have to just to follow the rules. Okay, 2 power r greater than or equal to m plus r plus 1. Power of 2 positions only you have to add parities. That is how you have calculated. Yes, correct, Anushka, correct. Yeah. So please try this next question. Yeah, this question is the subtopic called MAC layer, medium access control sublayer, how they are asking. Especially regarding what? CSMA by seeding. Out of pure Aloha, slotted Aloha, CSMA by CD. CSMA by CD is the finalizer technique in detecting the collisions, because that is a shared channel. In every station is going to participate. When they transmit the data, the actual transmission of the data is going to begin only after acquiring the channel. So please try these options. This question. Yes, Ashwant, you can take a reverse order also. See, the point is in the Ashwant is asking. See, the basic idea is you can take reversely also, no problem. Like that also you can take. Then what is going to happen here in this question? If you take reversely, this entire thing you can take reversely also. When we are following the rules, you will get the same codes. Yes, it is going to work. Yeah. Abhishek, correct, very good. D is the answer, good. Abhishek, very good. See, a station, see the option A. A station stops to sense the channel once it starts transmitting the frame. No, because if you observe the CSMA by CD, parallelly the two things are going to happen. Parallelly you transmit a signal and parallelly you are going to sense the channel. So these two programs are going to run, because when you are sending that signal, you want to maintain that signal strength as moderate until the time of 2 into PT, because the entire channel, one side is PT and the other side is also PT. If you are able to maintain the signal as moderate till the time is 2 into PT, it's confirmed that you have acquired the channel, then you can start sending your data. But here you see what they are saying, that the station stops to sense the channel once it starts transmitting a frame. So this is the false statement you can say. So A is what? False. So go for the option B. Yes, Anushka, correct. Sagar, very good. Varun, Abhishek, Jimmy, correct. Option B. The purpose of the jam signal is to pad the frames that are smaller than that of minimum frame size. No, see, basically, see, the idea is very simple and logical. See, suppose if I have taken a bus topology, so you can see this is a bus topology, station 1, station 2 and station 3 and station 4, they are connected. So basically, if you are transmitting some signal and from the time of t you are sending, somewhere there is a collision has happened, okay. So the point is, it is giving you a clear idea, the stations are spread on different places of this entire cable. So whenever there is, we can say whenever there is a collision, so it is giving you a clear idea, only the nearest station will be knowing about this collision. So this collision energy, the collision whatever thing is happened, it has to know to all the stations actually. So for that, this purpose of jam signal came into picture. So to convey that, so indirectly the signal is telling, it is jamming the entire network, telling here some collision has happened, nobody has to transmit the data. So the main purpose of the jam signal is to inform unknown stations about this collision. Okay, it is not just to add some pad bits to MTU. Okay, it is to inform that somewhere collision has happened, or you can say mixing of the signals has been happened, the signals which are transmitted by the different stations actually. You can see the purpose of the jam signal is to pad frames that are smaller than that of minimum frame size. So this is also false. Okay, yeah, try for the option C. Yes, everybody has told correctly. Abhishek, Varun, Sagar, Anushka, correct. Now you see options. A station continues to transmit the packet even after the collision is detected. So this is false now. See, basically once you know aware of that the collision has been happened with the help of this collision detection mechanism, why you continue, and you know if you further continue indirectly, if you again start sending immediately, the chance of collision is high. So what is the actual procedure? You have to wait some random amount of time. That random amount of time with a probabilistic analysis, you are going to apply that using exponential back-off algorithm. You know very well about it. When you apply exponential back-off algorithm, as the k value increases, the chance of collision is going to decrease, or the chance of data reaching safely by that computer is going to increase, because the collisions will be less, the throughput will be high, you can say. So that is what you can see, it is mentioned in the option D. The exponential back-off algorithm reduce the probability of collision on the retransmissions. Like when k is equal to 1, the chance of collision will only be 50%, k is equal to 2, the chance of collision will be 25%. So here you can say D is the correct answer. So out of all, whether you are asking true or false statement, true statement, you can say D is the answer for this particular question. Good, very good. So you can, this is how in the MAC layer the questions are asking. See, it's not like always the IP addressing questions we can easily solve subnetting or supernetting, or it's not like always we can solve the data link layer questions only. It's once your concept is clear, every question you can easily solve. Okay, that's to convey that message only I am giving the different model questions. Also, it is not just IP or the frequently asked questions actually. Even the MAC layer, the questions also you can easily, precisely and clearly you can solve it once you know the concept, what is happening in that particular MAC layer, you can say. So, and you are able to solve it. Yeah, you can go for this question. So, this question comes under the MAC layer, medium access control layer, and how the questions in the some of the PYQs, how they are asking the probability mixing with the MAC layer. So, this is how this question is given. So, read every word in it and try to solve it and tell me the answer for this question. See, LAN. LAN means what? Local area network of the MAC layer. Please try. Yeah, there are 5 nodes N1, N2, N3, N4 and N5. There is a fixed size slot timing. It is to convey that every slot time is fixed. Okay, they are not changing. It might be a microsecond or some time, that time is fixed. Okay, in the network. Any node can begin its transmission only at the beginning of its slot. See, if the total time is divided into slots, it's not like the system is ready with the data you can transmit. No, only at the starting of the time slot, the station can transmit. Suppose a particular station is ready with the data before only, no, he can't transmit, only at starting of time slot he can transmit the data. That is the meaning of that particular question. So, basic idea why they have applying these mechanisms is to increase the throughput actually. Yes, Akash Chaudhary, very good. Good, Akash Chaudhary, correct. Anushka Srivastav, excellent, correct, good. See the probability of transmission of frame, because in the data link layer frame only, see the probability of transmission of frame in its time slot for N1, N2, N3, N4, N5, because all the stations are having the data, but they are using the probabilities, and you can see they are mentioning equal probabilities like 0.4 they have mentioned. So, why this concept of probability came into picture? Because the stations which they are spread on that particular shared cable, so whether they can send or they can't send also. If they don't have a data, they don't send, but if they have a data, once the slot is ready and it is having data, the chance of transmitting by an individual station is 0.4. What is the use of applying this probability? See, when the chance of transmitting is 0.4, the chance of not transmitting going to become 0.6. So, obviously, when a particular station is not transmitting at 0.6, is it not, it is giving a chance for some other station to transmit because it is not transmitting. So, obviously, when you give a chance for some other station to transmit because you are not sending, the collisions will not happen. So, basically, the data will go to destination. Obviously, throughput is going to increase. That is the basic idea of the MAC layer actually. See, what is the probability of sending a frame in the first slot without any collision by any station? So, then any station means it can be any station, first station or second station. Then what is the formula you can apply? Okay, NC1 into P power 1 probability of transmitting by only one station. Okay, because if only one station is sending, remaining all stations they are going to differ, then only there won't be any collision, then only data is going to safely reach the destination. So, when a particular station is transmitting with the probability P with one, only one station, then remaining n minus 1 should not transmit in the same thing actually. That is why here into means what? Remaining stations should not transmit. Then why it is n? It is only should be one station na. It can be any one of the station. It can be one or either second one or third one. So, when you say plus 1 plus 1 plus 1 n, it is going to become n. So, it should be 1. So, this we can say NC1. So, how many, what is this n? Number of stations. Number of stations are how many given in the problem? So, it is what? 5C1, because 5 stations are there. Now, it can be any one of the station. What is the probability of transmitting the data by individual station that is given in the problem? It is 0.4. So, when a particular station is transmitting 0.4, remaining 4 stations should not send at the same time. It is 0.6 whole power how many stations? It is 4. So, calculate. I think everybody has solved. How much is the answer? Good. 0.25. Yeah, 2592. Yeah, good. Very good. 0.25. So, this is how, if you observe some models of PYQ, they are asking the questions. The basic idea is to increase the throughput so that you can increase throughput. Definition is what? The successfully receiving the data that is going to happen when the collisions are not there, you can say. So, this is how the questions they are asking in the MAC layer. Yes, very good. Everybody has done. So, go for the next question. Yeah, please try this question also. This also comes under the MAC layer only, medium max control layer. See, the Poisson distribution is applied in the MAC layer because the arrival rate, or we can say the model, the number of frames which are transmitted depends on the number of stations which are having the data and they want to transmit. It is not always fixed at a particular time now, because when the channel is a non-deterministic, which you can't determine when the stations are going to transmit. So on average, if I take a particular time, how many stations will transmit is going to differ. When that is the situation, you are going to apply this Poisson distribution. You might be at a +2 or 10th, you might be studied some problems like defective bulbs are there. What is the probability that these many bulbs are going to be manufactured? Such type of questions you are able to have solved in the Poisson distribution. Same like that in the MAC layer also, they are asking in the the gate, the computer networks. So this is one of the question. You please read every word in it, you will get a complete idea. Yeah, try this question. Yeah, see, it's not like always easy questions may always will be given, this pattern only will be given, because the questions can be given by the different IITs, some IIT centers. You can see sometimes it's not like I can solve IP addressing questions, fragmentation questions or application layer questions easily. They can give this MAC layer questions also. They can give the data link layer questions also. They can give in the network layer traffic shaping also. But how to approach them, and here we are guiding you by solving such questions also. Mishra, very good, 135, good. Yeah, see, you will get a 0.135, but you see the final question what they are asking, you got a 0.135, okay, but what they are asking, you see how they are defined. So let me give the information of every word in this question. See, consider a network using the pure Aloha protocol. So pure Aloha is a shared protocol, you can say, medium. Where each frame is of length 1000 bits, where each frame is of length 1000 bits. So it is telling that the stations which are participating in that protocol like pure Aloha, each station can transmit 1000 bits actually, 1000 bits. The channel transmission rate is 1 megabits per second. So whatever the channel, the cable you are taking, so you can transmit at what, 10⁶ bits per second. So I can write like this. So the transmission time of a particular station on that shared channel of that pure Aloha. So how do you can say that it is each frame whatever you transmit, it is 1000 bits that can be transmitted in the pure Aloha, and they have given the transmission rate or the bandwidth is given as a 10⁶ bits per second. So in that shared channel, see, the protocol is a pure Aloha. So pure Aloha rule says what, any station is having the data, they can transmit. So on that channel, when you say a word like any station is having a data and they can transmit, and you can see there are no fixed size time slots, because it is not a slotted Aloha, it is a pure Aloha. So not only this particular station, remaining all stations also they can transmit anyway. So if you calculate, this is nothing but a 10⁻³ you can say this is the time, or I can say 1 millisecond, you can say, or basically here I can say one word like one frame can be transmitted in the pure Aloha by a station in a time of 1 millisecond as per the given data we have calculated actually. Okay, that is the meaning of it. Yes, Akhilesh Mogra, correct, very good, correct, Mogra, correct, 135. Let us further read the question. See, the aggregate means what? The summation, you can say. The aggregate number of transmissions across all the nodes, including the new frame transmissions and retransmitted frames due to collisions. Okay, why they have mentioned that the frames which are transmitted by different stations and also the new transmission, why do they mention? Because the protocol is a pure Aloha. When the stations are transmitting at different times, possibly the chance of collisions will be there, and when they apply the back-off algorithm, again they are going to retransmit because of loss of the data. Okay, so that is the meaning of it. Why do they retransmit means what? Because it is a pure Aloha. If the packets which are suffering from collisions, they have to be retransmitted. Anyway, is modeled as a Poisson process with a rate of 1000 frames per second. That means this Poisson process telling that if we given a time of 1 second, totally 1000 frames are transmitted. And you see the beauty of this particular what you can say question, they have mentioned in 1 second 1000 frames. This 1000 frames is the successful frames actually. How do you can say that successful? In the meaning is what? Meaning is what? It is both the transmissions as well as the new transmissions as well as the including new frame transmissions and the retransmitted frames. So basically it is giving a clear idea. In this 1000 frames, some frames which are lost are also involved in it because you are doing the retransmissions now. That is the meaning. It is given by the Poisson process. Okay. So how do you write here? The Poisson process telling like this. Okay, the Poisson process, it is telling that totally 1000 frames are can be transmitted in a particular second. See this word, in a second, in a second. And you see whatever the 1000 frames you have transmitted, it is the frames just suffering from the collisions are also involved. Now you see the logic now, the main logic is here. See, you have already calculated for 1 frame in 1 millisecond when you transmit 1 frame. Is it not you are able to send 1000 frames? Is it not you are going to transmit 1000 frames in 1 second? Because if I multiply this right side by 1000 and left side by 1000, 1 into 1000, 1000 frames, this millisecond is going to become 1 second. So this is how in the case of that pure Aloha, in 1 second, the different stations on whole, they are transmitting 1000 frames actually. But Poisson process also telling na, it is 1000 frames per second. So based on these two, now you can calculate the G value. The G value is called channel load na. Here also 1, here also 1. So this is call it as 1 na. It is 1000, it is 1000. It is not underloaded, it is not overloaded, it is critically loaded because G is equal to 1. When G is greater than 1, it is called overloaded. When G is less than 1, it is called underloaded. But G is equal to 1 because you can say exactly this number is matching with this number. So now you can calculate the throughput now. Tell me, how do you going to calculate the throughput of the pure Aloha? And the throughput of pure Aloha, which is given by, okay, Poisson process, by applying that Poisson distribution. What is that S value? Throughput is the successfully receiving the data. This you know it is G into, see the protocol is a pure Aloha. This is G into e power minus 2Z. If they ask for a slotted Aloha, it is G into e power minus G, na? Because the vulnerable time is going to reduce to half. So now you already know G value 1 you have calculated. So substitute here. So 1 into e power minus 2. So this is 0.135 is the throughput. So what is the meaning of 0.135 means? So simple. When you transmit 100 frames, 13.5 is the success. But here you are transmitting 1000 frames. Na? For 100 frames it is 13.5. Then for 1000 frames it will be 135. Na? So what is the answer? 135 is the answer. Mugra, correct. Mishra, correct, very good. See, even if we forget about that throughput definition, see, they have mentioned in the problem itself. See, throughput is defined as the average number of, on average number of frames successfully transmitted per second. So that's what they are asking the, see, the average number of frames, they are asking the frames actually. What is the answer? 135. Good. Everybody has done correctly. See, normally the throughput you should not remember with a equation because it is changing from protocol to protocol. Normally throughput meaning is, definition is what? The successfully receiving the data to the receiver is called it as the throughput, you can say. Based on the protocol, how much time you should take, it is going to differ actually. Okay, suppose you see, if I am a ground station, you are transmitting the data only to a satellite. The satellite, whatever it is receiving the frames successfully, that is going to become the throughput of that contents actually. In some other case, what is the throughput of the from sender to receiver, and again getting back to the acknowledgement to the sender also they are going to consider. But here you see in the case of MacClear, how do you define a throughput? Means the Poisson process telling it is not just the frames you transmit, the retransmissions also you include it because the collisions are there. So transmissions plus retransmissions combinedly they are called, written as a throughput here. The basic idea is successfully receiving the data is called throughput. Okay, I think somebody has asked this question. Yes, Mishra, correct. If it is slotted Aloha, the answer will be, you have to apply G into e power minus G. Very good. Yes, then you will get some 368 like that. Okay, good, very good. Good, very good. So you can try the next problem in it. This is also MacClear. This is also MacClear problem you have taken. Read every word in it, so you will get a clear idea what exactly they are asking. Yeah. So I am going to give the hints for this problem. Let us see here. See, consider 4 active nodes. See, active nodes means what? It's not necessary that the stations which are connected in the shared channel, they have to transmit 100%. Some, they may be passive nodes also. Okay, active means what? They will have a data in and around, then you can call them as active nodes or active computers. A, B, C and D are competing to access for a channel using slotted Aloha. Now you see the question is not pure Aloha, it is the slotted Aloha. Assume that each node has infinite number of packets to send, okay, and each node attempts to transmit in each slot with a probability 0.5. Okay, so why do they have mentioned that infinite number of packets are to send means what? See, the basic idea, the stations whichever they are connecting on that shared channel, it is having a steady queue of frames, means continuously the packets are coming. So that is the reason they have mentioned that infinite number of frames are there. See, basically whatever you send a complete message, the message will be divided into segments, segment will be divided into packets, packets will be divided into frames. So when you are sending a very large message, obviously once it comes in the frames, the total quantity is going to increase now. So that's why they use a word like continuously they have this infinite number of frames. Anyway, let us come to our problem. So the probability of transmitting is how much? It is 0.5. Yeah, the probability of node D success in transmission for the first time. So this is the important to say first time in the 4th slot. Okay, this is a very important point. You can see they have given a hint in this problem. So how many stations are there like A, B and C and D? I hope A, B, C, D are the active nodes you can say. So now active stations actually. So how does the total time is divided into slots like slot 1, like slot 2, like slot 3 and suppose say slot 4. So here we will talk about the 4th slot. See, they are telling that in this 4th slot station D has got a success. So the question is regarding the station D only. So the basic idea is here this station D has got success in the 4th slot first time. So this is the hint that is given that station D has not got a success in first, second and the third slot actually. Okay. So, the meaning of success means what? Whatever the station is sending the data, if it is not suffering from the collision and the data is reaching to the destination, that is call it as the success. So, that success has got for station D first time at slot 4, it is giving a clear idea. Slot 1, slot 2, slot 3, it is the failure actually. So, first of all tell me what is the success of station 4 that and the slot 4. What can be the success for the station D in slot 4? We can say the probability of success is what? P. Suppose for station D, if it is P actually. So, into, why into? Because when this D is trying to transmit, then A, B, C should not send, then only you can say it is a success for station D. Then why? Because there won't be any collision. So, basic idea is the probability of transmitting the data by the station D in the fourth slot is P. Then for A, B, C it should be 1 minus P. How many stations? A, B, C, count, there are 3 stations. So, this is 3. So, this is the success for the station D in the fourth slot you can say. So, they are mentioning that probability of transmitting is 1 by 2, 0.5 means 1 by 2. This is how much? 1 minus 1 by 2 whole power 3. Say indirectly it is 1 by 2 whole power 4. So, this is the probability of success in the fourth slot actually. Now, you tell me, once you know the probability of success for station D, so can you calculate the probability of failures in these 3 slots by station D? It is very simple. If success 1 by 2 power 4, I can write this is nothing but 1 by 1 minus 1 by 2 whole power 4 is the failure for station D in the slot 1. Here also 1 minus 1 by 2 whole power 4 is the failure for station D. Here also it is 1 minus 1 by 2 whole power 4. It is the failure for station D. Because they are asking success should be at the fourth slot first time. So, this is the total analysis. So, now we can write like this. This is nothing but 1 minus 1 by 2 whole power 4 whole power. So, for how many slot? First, second, third, whole power 3. These all should be the failure for station D into the fourth slot D should be successful. It is how much? It is 1 by 2 whole power 4. So, this is the final answer. Calculate, you get the answer. Here you can ask one important question. Sir, instead of solving like this, why can't I try for a station A failure? Then I can go for a D. See, the point is, when you say that D is failed, if I say I will try for A, okay, A can be a successful, we don't know na, whether A is successful or B is successful or C is successful individually. That is one case. Second case, A B is successful, B C is successful or A is successful, we don't know, or A B is successful. So, why these all calculations? The best way is, our target is station D should fail, that is all. This is the best idea na. If you know the success here, this is the best idea. So, that is how you have to approach and solve the problem. If I say I will start with A or B, these are the different scenarios you are going to get, which will lead to the confusion. So, the best idea is let the station B D make it a failure. You will get a failure for this one if you know the success for this one. This is so simple. Okay. So, please tell me the value for this one. You will get 0. How much? 0.051. Please calculate, you will get the answer. 49, okay, like this. You can take up to 2 decimal, this is the value you are going to get. See, this is how they can ask the questions in the MAC layer, you can say in an easy way. But for that, so everywhere you require must and should, you require what? The probability. Not only in the MAC layer, you see in the sliding window protocols also, how do you define once a frame is received to the receiver data link layer, the sequence number of the data is compared with the receiver's window size. If it is matching, you accept. If the sequence number is mismatching, you don't accept. So there also you are applying the probabilities only. So throughout the entire networks, must and should you require the probability logics actually. Then you check, everybody has got this answer or not, you check. I think some Mishra and Jimmy is asking question. That's what, if I start with A, we don't know, like whether A is successful or B is successful or C is successful. Why to calculate all these things? Just make D, we want D should be failure, that's all. Okay, got it? Good, very good. Yeah, so try this. So far we have covered this MAC clear questions, some of the model questions. Yeah, you can try. This is also a very easy question regarding this is the IP addressing. Okay, this is the IP addressing model. Try. It's very easy. See, there are three machines or computers with IP address 100.10.5.2, 100.10.5.5, 100.10.5.6. The subnet mask is given. You can see it is 255, 255.255, 252. You can see it is 252. 252 means what? 6 ones and 2 zeros. This 6 ones and 2 zeros means host bits will be 2 bits. Or you can say in all these three IP addresses, the fourth octet which is having here 2 and 5 and 6, in that 2 bits will be the host bits. See, even you are able to solve the questions IP addressing and related to that every question, whether it's a diagrammatically or any question in the gate, it's not always that these questions only will be given. They can ask in the MAC clear, they can ask in the flow control. So every model we are able to solve now. So that is how you have to approach any question that is given, because they will be prepared by the question papers prepared by different IITs actually. Okay, it is not always the same IIT, like that. Yashwant, correct. Mogra, correct. Okay, only N and okay P. So C, we can say here C is the answer. Okay, C is the answer. So how? See, this is 2 and this 5 and this 6 convert into binary, you will get the answer. Why only this ending octets? Because you can see remaining 3 octets is same, so prefix is same. So you can able to distinguish only with the help of this fourth octet only. Okay. See here it is written. See this 5, whatever we have written, if you observe these 6 bits, you should not, the prefix is same, and you see since prefix is same for 5 and 6, we can say these two belong to the same network. So N and P belong to the same subnet. But you can see the first address is 2 na. If I write this 2 is nothing but what? Here it is 6 zeros and 1 0. But you can see the prefix is mismatching with the remaining 2 prefix. So when the prefix is mismatching, this gives a clear idea that this M is in the other network. So only N and P belong to the same subnet, you can say. Okay, so what is the answer? C is the answer for this question. Good, very good. Yes, Mishra, correct. Yashwant, very good. Anushka, very good. Correct. Yeah, you can try this next question also, next model question also. Good. Everybody are solving correctly? Good. See here the hint of this question is they are just mentioning should not be used. See, should not be used. So I'm going to read every word in this question. Suppose computers A and B have IP addresses, like here you can see it is 113 and it is 91. So if I write, I'm going to solve parallelly along with you. This is 113 and second one is 91. So if I convert into binary, this 113 I can written as 0, 111 is 112. So followed by 3 zeros and 1, because 112 plus 1 is 113. So 91 I can written as 0101 is 80 plus 11 is 1011. So that is how these two addresses I have written. See, they are asking should not be used. Should not be used means what? Prefix should differ actually. See, out of all the options, you don't require to worry for the first 3 octets actually, because it is same. Ending octet you say 0, 128, okay, 192, 224. Suppose here if I have taken here this 224, 224 how do you write? 3 ones and 5 zeros actually. So these 3 ones are the subnet bits and remaining are the host bits. So this gives a clear idea. These 3 ones along with the remaining 24 ones is the prefix, remaining 5 are the host bits. So if you observe here, these 5 are the host bits, and you can see here the prefix is deferred. You can see prefix is deferred. Since prefix is deferred, they don't belong to the same network. That means if I use this option D, okay, say should not be used if A and B should belong to the same network, because if I use this, we can say that they are not in the same network. You can see. See, the basic idea is if I go for option A, these both computers will be in the same network. If I go for option B, then also both will be in the same network, these two IP addresses. If I use option C, then both the computers, that 113 and 91 will be in the same network. But if I use this 224 as a mask, these two computers can never be in the same network. Why? Because you can see prefix is deferred. Prefix is deferred means what? Network is deferred. That is the meaning of the question. Yes, Aish, correct. Anup Jain, very good, correct. Jimmy, correct. See, the basic testing of this question, how far you had an idea of knowing the IP address. Why? Because the basic idea is in the entire internet, the communication will be done between the end computers with the help of the IP address of any destination computer. That destination IP address formats, you should know what is the prefix, what is the host bits, because in the same prefix, the hosts which are in the same network will have the same prefix actually. So that test, they want to test your knowledge, how far you had depth of the knowledge of the IP addressing in the network. Basically, because any system, whenever you want to transmit the data to a end computer which is very far away in the internet, you should know that IP address. So for that, you should know the format of it. That IP address is a logical address. Okay. So whether it's the same network or a different network, same subnet or a different subnet, or in the same SOPANet or a different SOPANet, you should have that knowledge. Yeah, thank you, Lavanya. Yeah, nice explanation. Okay, good, thank you very much. Yeah, some students are commenting. Nice explanation, good. Yeah, so this is the answer. So if you observe so far, whatever we have covered, this 14, all the questions, we covered some questions of the data link layer, the MAC layer, and some IP addressing questions. Okay. Yeah, please try this next question in it. So this question is to guide you, like how well you had aware of all the layers when a web client or a client which is hosted on a particular computer, a client browser, when it is connecting or communicating to a server which is hosted on a particular website, what are the different sequence of serial steps you have to follow when you are actually accessing some object or a content from the server. So based on that basic knowledge, they are giving such questions. So please try. If you had a doubt, I am going to guide it. Identify the correct sequence in which the following packets are transmitted on the network by a host when a browser requests a web page from a remote server, assuming that the host has just restarted. Just to switch on the computer and you are connected to the internet for communicating to a server, they are asking. Please try to analyze, because this is a very important concept, you can say. Fanstar, Jimmy, Piyush, Sumit, Anushka, Mogra, very good. See, the first important is DNS query. Obviously, it's a DNS query. Why it is so? See, basically whatever you type some URL on the web client browser, that URL directly it will not go to the server where you are communicating. First, that query will go to your local router. If you don't get the answer like IP address, then it will be forwarded to the immediate ISP, which is a default gateway. Where you don't get that answer, then it will forward to a root server. If you don't get there, then finally the top level domain, and then in the authoritative DNS server you will get the complete IP address, and then from that IP address you are going to contact that web server. So the basic idea is, first of all, any website which you want to access, you should know the IP address of it. So for that, it has to contact a DNS server, where the DNS server is going to listen at port number 53. Maybe it is using a remapped port, that's a different story, but possibly the DNS server is going to be available at a port number 53. So the basic idea is DNS. So this gives the first idea. You can eliminate this A and you can eliminate this D from the given options. So you can go further now, B and C. You can see HTTP GET request and TCP sync. This is a very important thing. See, basically any application layer protocols like HTTP or the SMTP or FTP, they will depend on the below transport layer TCP protocol for connection establishment. That connection establishment is a virtual connection with the help of the sync segment. So basically that server is going to listen at some predefined port. So if that port has to be accessed, the TCP is going to help for the connection establishment. See, it doesn't mean that the packets will follow the same path. Even the packets, they follow different path. The TCP is a connection oriented virtually, you can say. So this gives a clear idea. So this TCP sync segment will come. So now you can eliminate this B also, you can say TCP sync for the connection establishment virtually. Then only that socket, whatever it is there at the server, that port, whatever it is in the listen state, it will move to the established state by sending the ACK. Once connection is established at that server, the TCP buffer space, some variables already will be allocated, some resource will be allocated to that specified client, whoever the connection is established. Until and unless this TCP connection is not established, the resources at that server by the TCP will not be assigned to that client actually. Understand? See, these days because of the drawbacks of like head of line blocking in the TCP, now this YouTube or some other protocol, they are going for a quick protocol, but that is a different story. Like the TCP implementations are already done at the application layer with a quick protocol. But in terms of this particular general scenario, first you should get the TCP actually. So then only the HTTP GET request. So you can say C is the answer for this particular question actually. Since it is a HTTP server, it is then going to normally it is going to host at going to listen at a port number 18. if it is a HTTP, or else if it is providing secure connection with the help of that socket, in place of 80 it is going to listen at 443 actually. So you can say this is the C is the answer, you can say. Yes, Akhilesh, Yashwantre, very good. Everybody has done correctly. Yeah, so please try this next question, 17th question. See, the basic idea of this particular question is to tell about a router. It is not always the same, the router which you are using to the immediate LAN network and also the default router as well as the ISP router where you are connecting for the internet access. These routers are okay, but in the internet some routers are going to form a group where they form as an autonomous system for routing the data packets. So every routers which you use for the immediate LAN will not, the functionalities will not be same as the actual routers which are providing the routing in the internet. So based on that, this question is given. So please try to solve it. I am going to guide you. If you had a problem, okay, try this one. See, some of the PYQs we have taken because basically you should know some terminology how they are asking, like some new terminologies like here they have used something like IP based router. So to have a clear idea, we have picked some questions and we have given. Okay, that's a point in it. Because it's a, see, like we say they use some words like a default router, or they say that ISP, they will say some routing router. It's not like only the PYQs we picked on it, okay. Like the group of the questions we have taken, so that some specific questions also how to solve it we are giving it. You can see the first one, a router doesn't modify the IP packets during forwarding. So that is the first one they have mentioned. See, basically if you observe, see the actual message whatever you transmit, if it is divided into segments and then packets, these packets after passing via this particular default router, they will be scattered. The packets will be moving in different paths. And when the packets are moving in different paths after the ISP and they are entering into internet area, so how does this routers intelligently they are going to forward? Means they don't check the every bit of the packet. In an intelligent manner, they are going to observe only the header part of that particular packet, specifically the IP header. Based on that, routing of the data packets are going to happen. So based on that, we can say that IP header parameters will be modified by the router, something like some parameters like a TTL value or some other parameters you can say. So basically here the routers are involved in routing the data packets with the help of the IP header, so they are going to change actually. So you can say here they have mentioned that a router doesn't modify the IP packets during forwarding, so this is the false actually. And if you observe something like in the advanced computer networking courses where IITs and some other universities are giving, if you observe their focus is like presently whatever we are learning the computer networks as per the GATE syllabus, in future how the things are going to happen based on that some idealistic considerations, those topics are designed. For example, here you see such questions whenever the clients are transmitting data or receiving the data, the basic idea is they want to get the data from that server and these routers are only just forwarding or routing the packets. But in the advanced computer networks, what they want to convey is, why does that content has to be hosted on the server only? Can these copies can be available at in between the routers? So such type of topics they are available in the advanced computer networks. Here you see this question is dealing something like the routers are only analyzing the IP header and then forwarding the packets. Instead of like that, why does the client, whatever they are asking for a content, that might be hosted in this in between routers only, so that they can immediately forward? Such type of topics, like some other topic like high performance routers. High performance routing comes under in these days, because the bandwidth with whatever they are providing these days are like gigabits and terabits of data. So whether the routers are highly capable of processing those packets in that much fast manner, that high performance routing, how it is done, it is available in the advanced computer networks actually. So these topics are involved. That is the main difference between the basic the computer networks what we are learning in the GATE and in the upcoming in future whatever you get, because these all the bandwidths, whatever the megabits or gigabits like that, now we are using the gigabits of bottleneck bandwidths and terabits of bottleneck bandwidths are there. So in future these mediating routers also they can get the total content also. Anyway, let us come to our discussion of this question. So that is how a router doesn't modify the IV packet during forwarding is wrong. Like you can see the TTL value is decremented, header checksum is calculated, so some fields are going to change. Now if you go for option second part, see, it is not necessary for a router to implement any routing algorithm, so it is true. Why it is so? Basically, you see, if you take a LAN network where all the computers are connected to the immediate local router, then all these packets will go in a straight line to the immediate ISP router. So this local router no need to apply any routing algorithm. Directly the packets will go to the ISP router, default router you can say. See, from that ISP router onwards, when the packets are routing, there you can apply some routing algorithm like RIP or OSPF, something in the autonomous system like that. But from your local router or from the firewall, when the packets are going to that ISP router, you don't require to apply any routing algorithm. Obviously, they ask to follow the straight path only. So that's why they are saying that it is not necessary for a router to implement any routing protocol. Some case it is true, so that's why we put a tick mark for it. Third one, a router should reassemble IP fragments if the MTU of the outgoing link is larger than the size of the incoming packet. So this is false now. See, the basic idea is when the packet size more than MTU LAN, then you divide into fragments. But if it is always, obviously if it is small, what is the need of dividing into fragments? But they are telling it will be allowed. So that's why it is false. So out of all, so what is this one? The 2 only. So we can say D is the answer for this question. See, it's not like why we such questions are given and we are solving. You should also know what is the meaning of high performance router, or what is the something like quick protocol, how it is working, how the head of line, these all things are available in the advanced computer networks subject of where this in the MTech course it will be available actually. So there whatever we are learning, how the routers are forwarding the data packets just only by analyzing the IP header, how the different paths they are forwarding, that is what you had in your syllabus. That's what we are solving the questions. Yeah, Piyush, correct. Kritika, correct. Anushka, very good. So D is the answer. Yeah. Yeah, please try this question. Yeah, I am just going to guide you some statements like this. See, basically when you are going for HTTP protocol, when a particular client is contacting a particular server, the browser is going to take the help of the TCP for establishing the connection to the server with the help of the socket. But during that time only, at the header of the HTTP, it is going to mention what type of method you are using, what type of connection you are using, whether it is a persistent or a non-persistent, and when you whatever you want to access that object or a content from the server, some information in the response it can mention actually. So based on that, this question is designed. So please read every word in it and tell me the answer for this one. Yes, Piyush, correct, very good. You can say you have made a request for a web page through your web browser, because without any web browser it might be the Mozilla Firefox or a Google Chrome or a Safari. Via that browser only you can contact the server where you type the URL and the application layer. Anyway, initially the browser cache is empty. So browser cache is what? Empty means what? You are not getting the content from your local OS or that local router or ISP directly from the server. You get that because the buffers are empty. So anyway, so further continue the question. Further, the browser is configured to send HTTP request in see this is the important non-persistent mode. Just now I have told you na. So like there will be a persistent mode, non-persistent mode. Persistent mode with the pipelining. Pipelining is something like a go back and ARQ. In the request you can ask for a multiple objects from the same server, or you can also go for a non-persistent HTTP with a parallel TCP connections. So what type of connection the client is trying to access the objects, it will be already configured in the browser only. That's what it is mentioned in the problem. Yes, Kratika, very good. Mogra, good, very good. 6 is the answer. Anyway, the web page contains a text and 5 very small images. So the text and the 5 images combinedly, the 6 are treated as the objects only. Okay, objects only. Now you see they are asking, telling that non-persistent. See, the basic idea of non-persistent is to provide security. Security matlab what? Once you put a request to that server, and once you get the reply to the client browser about that object, so you are telling that please close the connection for the requested object. Once I got a reply, you are insisting the server to close the connection. Which connection? TCP connection, because you have enabled a non-persistent mode. Suppose if you have mentioned that as a persistent mode, what happens is once the client is putting a request for that particular object, after getting the reply from that server, that particular object, after receiving it, the client TCP connection will still be open for further requests actually, you can say. Okay, basically that is the meaning of it. So here you see they have mentioned non-persistent. So once you see, once you get that one text for the remaining next one more MS, one more TCP connection, one more MS, one more TCP connection has to be established. So that is the basic idea of this non-persistent. So minimum how many TCP connections means what? We can say 1 plus 5. The answer is what? 6 you can see. The same question if they ask for the, simply they change a word like a persistent, we can say in one single TCP connection, you can get all the images you can see. So who is going to tell what type of HTTP connection? That browser only, where every day you are using the browsers, what type of configuration is already predefined, so that is going to be mentioned. Yes, Mogra, correct. Good, very good. Yes, everybody has done correctly. Good. Yeah, please try this question. See, the idea is you should have awareness how the systems and devices are configured. You can see it is talking about some enterprise network. It is not just to tell the answer or to get the solution done. So why they are configured, why these parameters are there. So that is the idea of this question. Okay, see. Please try to analyze. Kritika is asking, can pipelining be done with a non-persistent HTTP? Yes, Kritika, we can do, but there what type of pipelining we say that parallel TCP connections you can use. I think Kritika is asking one, Madan, I think Madan is asking one question, can pipelining be done with a non-persistent HTTP? Yes, you can do, but there is a restriction. See, the end devices these days are coming with a high capability computers where multiple processors will be there. So that is based on that you can go for a non-persistent 5 parallel TCP connections you can have, so that the end system's performance can be increased. That means in a single connection, okay, you are asking for a non-persistent, no? 5 parallel TCP connections you can ask and request for the 5 objects. Then such a case we can call it as a non-persistent with the parallel TCP connections. So that parallel TCP connections comes under the pipelining only. But there is a limitation that whether the 5 parallel TCP connections or 10 parallel TCP connections, there is a limitation. I hope your doubt is cleared, Kritika. Yeah. Now you see this basic enterprise network, if you observe here, the idea is not just to explain the answer for this question. You see, this is the internet area, and here the firewall, whatever you place here, where this firewall is divided into 2 parts. Here you install one router, here also one router. Basically, let us think, what is the definition of a router? Router is used for connecting multiple networks, you can say, multiple networks. Every interface of a router can act as a single network. So now you can see, you just want to, if you observe here one very important point, a web server which is connected to this router, it is isolated, you can say. Basically, you can observe that via this interface, you just want to convey that I am connecting a network. Basically, a network is group of hosts, you can say. Once the IP address assigned to a computer, you can call it as a host. But have you observed one important thing? To this router interface, here we are connecting a web server. That means if on the web server you are installing some HTTP or some protocol, so the devices from the internet, when anybody want to put a request via this firewall, it will come to this router, and from via this server you will get the replies. So the basic idea is here, from the web server you want to provide a protection, and you just want to make isolate from the remaining systems in the enterprise network. The employees will be there in the company. So the employees systems are working in the different departments like marketing, finance, all these departments. They are isolated from this web server because they want to provide a high protection to this web server. So that point you have to observe actually. Okay, like that. Now the second important point what you have to observe from this problem, you can see to this router, these are the end computers in that enterprise network. So these are the computers which you provide an IP address, possibly the private IP address, because then only the computers can communicate in the LAN. And have you observed to this router, these end computers are separated, this router and these end computers, in between there is a Ethernet switch is there. Why it is so? The basic idea is this is a single interface. Why the single interface? You can't connect to the multiple computers via the single cable. How you are going to connect? So this gives a clear idea. This Ethernet switch is a multi-port switch where the one end of the router you are connecting, and the Ethernet remaining ports you are connected to the remaining all computers. So this gives a clear idea. It's not like the every interface of the Ethernet is not a separate network. This point you have to observe. Every interface of the Ethernet is not a separate network. This Ethernet or this cable or this device switch, whatever you are using, it is just to convey that this entire thing is one network only, a one subnet only, which is connected to this router actually. Because the router interface is only via that one network only you can connect. So now you can see, you can easily answer this problem. Now that is how you have to analyze. The basic idea is not just this question. If any other questions they have given in this format, you should be in a position to solve it. So that you can do once you know what is happening in the network. Here you can say this, I can call some marketing department. Here I can call it as some finance department. And in that company, here this is a web server where the important information or the service which you want to provide to the different users outside, so you want to protect it well with the help of that server, and you want to make it isolate from the remaining subnets, so we have shown separately like this. Now here you see, this is one subnet, one more subnet, this is one more and one more. You can say 1, 2, 3, 4, 5, 6. What is the answer? 6. See, the idea is not like you just to tell the answer as 6 subnet. You should know why it is configured. And one more important point, here there is a router, here there is a router, here also router. You can ask here why there is a firewall, you can have a router, none. See, the basic difference between a router and a firewall is, the router is for what? Routing the data packets. The main purpose is routing the data packets. So whatever you get the packets will enter and the packets can leave via this router. So the definition of router is routing the data packets, but firewall is not like that. The purpose of firewall is something different. Even it can work like a router, the main purpose of firewall is to provide a security to the data. So it can block a particular system, a particular service, a particular network also, and it can allow also based on the access list whatever you have defined in this firewall. So fine, for this the answer is what? 6 is the answer. So that is the idea of taking this problem. So basically, if any problem of this type, if it is given for this year or the next year, so you should be in a position to answer once you know how the different things are there. It's not like we have taken this from PYQ. You should know, like if something is differently given, if you know the every device, you can divide. Otherwise, you might be in a procedure of thinking that this Ethernet, this is one network, this is one more network, this is one more net, that leads to a wrong answer. If you know what things are there, for what purpose it is there, it will lead to getting the correct answer actually. Good, very good. 6 subnets are there. Yeah, so please try this question. See, the basic idea of this question is regarding, it's not the what you can say local router, or it's not the it's not the local router where you apply static NAT or dynamic NAT or port NAT, or it's not the ISP. It is actually the routers in the internet area, the routing algorithms which are implemented by forming a autonomous systems. What type of protocols normally are used and for what purpose? So based on that, this question is given. Please try this question. Yeah, we can analyze like this. See, these are the routers in the internet area. So these are not routers like it is not a local router, or it is not the ISP router where you get a internet access. So here I am taking the routers in the internet area like this, where the entire areas again will be divided into small parts. I am going to call them as autonomous systems like this. So I can call this as autonomous system 1, and here I can call it as the autonomous system 2. Like this I can divide into autonomous systems in the internet. So the basic idea why they have done so, to apply the divide and conquer principle, or to make the task of the router which is routing the data packets, the processing time it has to make less. So the involvement or participating of the routers to design or to apply an algorithm will be done in lesser amount of time. So we can say a router in one autonomous system, if it is transmitting the data to a router in the same autonomous system, so they are calling such type of protocols as intra-domain routing protocol. So here you can apply the distance vector or a link state and the brand name protocols presently they are using is one is the RIP protocol, the other one is the OSPF. If you are using a RIP, you can apply distance vector routing. If you are using OSPF, you can apply the link state routing algorithm. But a router in one autonomous system, if it is transmitting the data to a router in another autonomous system, so you can call such a protocol, you can call it as the inter-domain. So basically why you have to go for inter-domain? See, whatever you send the data packets, it has to pass via all the autonomous systems and finally has to go to destination. So there such protocol which is implemented this inter-domain, you can say such protocol is the border gateway protocol. Okay, we can say like this. So basic idea is, if you are using this routing information protocol, so for it is going to internally implement this distance vector routing algorithm. So the basic idea is, when a packet comes to a router asking for that I want to go to a particular destination computer with a destination IP, the core part of this distance vector routing is the router is going to depend on the neighboring routers, actually we can say about it. And this distance vector for finding the shortest path to every other router, internally it is going to implement Bellman-Ford algorithm, you can say Bellman-Ford algorithm. But here there is one more intra-domain, that is called OSPF, where it is going to implement link state routing algorithm, you can say. But here the basic idea is, here the routers, they don't depend on the neighboring routers, the routers are going to depend upon the links, you can say. It will give the total information of the entire path, actually you can say. You can see, and for this link state routing, for finding the shortest path to the remaining routers only in the autonomous system but not on the entire internet, is going to internally implement this Dijkstra's algorithm, you can say, for finding the shortest path. This gives a clear idea, this distance vector routing or this link state or this RIP and OSPF, both are the intra-domain only, where this BGP is the inter-domain, and this BGP is going to use path vector routing. So this is the basic idea, where this RIP is going to depend on the neighboring routers for routing the data packets, and this OSPF is going to depend on the entire links between the routers, actually. So if you observe this particular question, that is what option A is given, OSPF implements Bellman-Ford algorithm to find shortest path. This is wrong, na? You can see here this is OSPF is going to use the Dijkstra's algorithm for finding the shortest path. You can say option B, OSPF uses Dijkstra's algorithm to implement the least cost path routing. You can say this is the correct statement. Option C, OSPF is an inter-domain. You can see here I have told you that OSPF is only going to work only within the autonomous system only. It is not a inter-domain. So you can say this is also wrong. OSPF implements hierarchical routing, yes. Internally by dividing into areas it is going to. Once you have done the complete analysis like this, then only give the answer. Otherwise, it may lead to the wrong analysis. You see, now what they are asking, you see, they are asking the incorrect. Which are incorrect? You see, this is incorrect and this is incorrect. So as per this one, so A and C are the answers for this question. Akash Chaudhary, good, very good. Yes, Akash Chaudhary, correct. A and C, correct, good. Yeah, so please try this 20, okay. Please try this question also. See, the query is considered to host P and Q connected through a router R, okay. Suppose whatever the information they have given, see it is like this. So, P is a node and here Q is a router, they are just mentioning here, and basically this is the AND system, suppose say R. So, whatever the information that is given we are writing. See, the maximum transferable unit of the link between P and okay R, okay, P and R is 1500, okay. So, that is what here they are mentioning, that here the MTU value is 1500 bytes, MTU value is how much, 1500 bytes, and here the MTU value that is given in the problem, how much it is, okay, 820 bytes. Here it is mentioned that MTU value is 820 bytes. So, you know the MTU will includes the IP header na. So, here I can write this 1500 as 20 is the basic IP header and 1480 is the allowed data from the transport-led TCP if you are using 8. So, 20 is the IP header and the basic data which you allowed is what, 800. So, these are the allowable capacities which are given in the problem about this particular links you can see. So, if you observe further, understand this question, the TCP segment of size 1400 bytes was transferred from P to Q through R with some identification number. The segment size how much, 1400. So, basically the IP protocol is going to add the IP header to the TCP segment 1400 plus 20 you can say. So, here I can say the packet whatever you transmit in that the TCP data which is 1400 and here the IP header is the 20 bytes. Totally this is the packet size which you are transmitting from the source actually. So, once this packet is passing via this link, the packet is telling 1400, MTU is 1480. So, you can say this is allowing without dividing this packet into fragment, it will be available, it is allowed on this link. But once the packet came to this router Q, what is the problem? This packet payload is 1400, but its LAN is only allowing how much, 800. So, this gives an idea that this packet will be divided into two fragments, like each fragment you are going to add the IP header, okay, like this 20. So, what is the value here? It is 800. You can say that means out of 1400 already 800 is added for the first fragment. For the first fragment, okay, 800 is added. That means in the packet size of 1400, the first fragment occupies 800 bytes, and you can see that is a multiple of 8. So, you can take it. The leftover out of 1400, when 800 is already given, leftover is 600 na. So, that 600 you can place it for the second fragment. So, now you can see the total content size in the second fragment is how much, 620 you can say, and the first packet like that means this packet is divided into two fragments. Anyway, further read the question. Which of the following statements are correct? See the option A, two fragments are created at R and IP datagram size carrying the second fragment is 620 bytes. Obviously, here you can say A is correct na. How? You can see here we have analyzed that second fragment is occupying the value of 620 bytes you can say, 620 bytes. Okay. Now, if you read the second option, if the second fragment is lost, R will resend the fragment with a IP identification. So, this is wrong, na? because okay, B is what? Wrong. Second fragment is lost, R will resend with a, R is going to resend fragment with IP identification number. Okay. Now, if you go for option C, if the second fragment is lost, P is required to resend, okay, required to resend the whole TCP segment. So, this is true, we can say. Why C is true? See, basically the packet whatever you transmit from the source, that packet is divided into fragments in the network. So, when some fragments are lost, or when some fragments are lost at the receiver, you can't join all the fragments and the fragments will be dropped. So, once again, if the sender has to send, how can a sender can send the missing fragment? He will send a complete packet actually. So, that is what they are mentioning. You can observe that second fragment is lost, P is required to resend the whole segment actually. So, that is true. Option D, TCP destination port can be determined by analyzing only the second fragment. So, this is false now. So, why this is false means what? See, the packet contains IP header. Inside the data part, the TCP header is already part of it. So, port number will be available in the data. So, the basic idea is when you divide the packet into fragments, in each fragment TCP information will be already available, then the port information will be available also in the second fragment and also in the first fragment also it is going to be available. It is not just the second fragment. So, that is why it is wrong. Now, you see the question what they are asking, which of the following statements are correct they are asking. So, A and C are correct. This gives a clear idea. So, A and C are the answers for this question. Okay, A and C are the answers. Yes, Piyush, correct, very good. Akash, very good, correct. Yeah, you can try this next question also, 20 second. Yeah, this question also regarding the fragmentation only. You can see what is the query they are mentioning. See, consider an IP packet with length 4500 bytes that includes 20 bytes IP header. So, whatever they are mentioning, the packet size. Okay, so how much is the packet size which already includes the 20 IP, 20 is the IP header na, so the data value is 20, and since it is 4500 means it is 44, okay, 80 is the data from the about TCP or a UDP total value you can say, and that means this 40 bytes of TCP header also becomes a part of it, because when you do the fragmentation na, the routers will only absorb this IP header but not a TCP header, because this 40 bytes of TCP header is going to become a part of the data. That point you have to observe. Then the packet is forwarded to IPv4 router that supports a MTU. So, here I can say there is a LAN which is having the MTU that is mentioned in the problem of 600 bytes. So, this 600 I can written as 20 is the IP header and 518 is the allowed data. But you can observe one important thing, this 580 is not a multiple of 8. So, why we have to focus on the multiple of 8? Because in the IP header if you observe, there is a total length of field and there is a fragment offset. So, between those two variables there is a difference of 3, 2 power 3 is what? 8. See, total length they are providing you the 16 bits where the total length will tell you the size of the packet or the size of the fragment. But fragment offset, when you are multiplying by 8, it will give you the starting address of that particular fragment or the packet actually. And they do not provide the equal bit difference of 3. So, that is how once you get the total bytes in the fragment, if you divide by 8, you will get the first address. So, whatever the value you take, that should be a multiple of 8 you can say. So, based on that idea, if you understand this particular question, say this packet when you divide into fragments. So, here I can write this first fragment as what? So, I can divide this 20 IP header is added here to every fragment with some change in values, but here the inside value is what, 576 only. Why 576 is a multiple of 8, but this 580 is not a multiple of 8. So here I can take like this, so 8 into 7 is 56, so 2 more, so I can say it is 72, it is 576. Then you can take 584 now, but 584 is exceeding this limit of this 580, but 576 is allowed. So that is how you have taken. So the basic idea, when a packet comes to a router with the value of 4480, this packet will be divided into fragments, where the first fragment is occupying the space of 576 bytes from this 4480, you can say. Then for the second fragment, so then for the second fragment, it is going to occupy the next slot of next 576 bytes from this 4480, you can say. Same like that, the third fragment, it is going to occupy like it is 20 and 576, like that. It will continuously divide into fragments. Now, if you go for this question, assume that the fragment offset stored in the first fragment. So now for the first fragment, they are telling that it will start with what, 0. So basically here what we have done is nothing but what, these are nothing but the bytes in each fragment. Here in the given problem, this 4480 is the bytes in the packet, but here is 576, 576, these all are the bytes in the fragment, actually, because this packet is divided into the fragments. So basically this packet content is distributed by giving these bytes, and which we are considering as a multiple of 8. But what is the need of taking this as a multiple of 8? See, after this fragment of bytes, whatever you are going to calculate the fragment offset, this fragment offset is one of the parameter in the header of that IP packet, or the header in the IP header of that fragment also. So between these two there is a difference of 8. So whatever already you have calculated these fragment bytes, whatever you have calculated, if you divide by 8, you are going to get this fragment offset. Why this 8 is going to play the role? Total length and fragment offset difference is 3 actually. So anyway, so you can see if I divide by 8 means what, bring this 8 this side, you will get a 72. That means it is going to occupy 0 to 71, you can say. So that is the reason, or we can just try it like this. This is nothing but, so 8 into 72 by 8, 8 and 8 will cancel. You can see 72 is a integer value or a whole number you are going to get. So that is the actual reason why we are bothering about it should be a multiple of 8. See, even it is a 580, why we don't take here 580 from this particular 4480? If I take this 580, if I divide this 580 by 8, here I don't get integer. If I don't get as a whole number or natural number, if I don't get, then I can't represent that whole number, natural number in the fragment offset field. That is the basic idea of the maths, why we are taking a multiple of 8. So now then it is 72 to, it is just going to follow the sequence because it is from 576 means what, again 72. So it will start with 72 plus 71, if you add this value will be 143, you can say. So this is for second fragment, and third fragment will start with what, here you see 143, then it will start with what, 144, like that it will continue. So anyway, now you see the fragment offset stored in the third fragment. See the third fragment, what is the value? So 144. So here the answer is what? 144 is the answer. Yeah, anyway, I say some of the students are asking like this question. So we are able to understand everything, but especially for the last fragment, this is a very important point everybody is asking. Let me convey. Sir, here we are every fragment you are taking as a multiple of 8. See, it is obvious for the last fragment, it is quite tendency that after distributing these bytes in every fragment, last bytes whatever you left over for the last fragment, so it may not be having a multiple of 8. So we just say that there you add a padding bytes. So the question is it required to add a padding bytes to make it as a multiple of 8? See, the basic idea is whenever you write a code, whenever you write any code, here if you take it as a multiple of 8 for all these fragments along with the last fragment, just you can write it in the if statement. you don't require to write as else for the last fragment like that. So to decrease the lines of the code, you are telling that for the last fragment I am going to add padding bytes. But when you are solving the gate problems, is it required that always multiple of 8 should be there? Means it's not required. Then how does the receiver is able to judge? Means see the point here, especially for last fragment or first or any in between fragment also, suppose see, somewhere you got the last fragment. See, the basic idea is every fragment IP header will be there. So in the IP header, if you observe, there will be a total length field will be there for the fragment. There will be the fragment offset will be there. Okay, so the basic idea is from the total length we will get the total content or number of bytes in the fragment, and in the fragment offset multiply by 8 we will get the starting address. So for the starting address, if you add the total length value, you will get the ending address also. So basically when these fragments are traveling and finally reaching to destination, even remaining all fragments they came late, even the last fragment came, it knows that that is the ending fragment with MF as 0, and it also knows the end part of the byte also, so it is not required to have a padding bytes. But when you write a code, there we require a padding bytes now. So in the gate problems, you don't require to add, so while you are solving, you don't require to add +4 or +3 whatever you had, but in the coding part you have to write. Hope I have cleared that doubt also. Okay, so for this problem it is 144. Yes, correct, good, very good. Akash Chaudhary, very good, correct. This is what we have done this problem, na? Like this. Yeah. You can try this problem also. Yeah, this problem also regarding the fragmentation only. Please try. Yeah, so how to approach this problem? See, the IP header is given as 20 bytes and the IP packet size. So the packet size here I can, okay, written as 20 bytes is the IP header. Total packet is 4404. So I can written as 4, okay, 3 and 84 is the data bytes which are available in the packet, because 20 is the IP header they have mentioned. So the value of the relevant fields, and they are mentioning the MTU value, and here there is a router, and the LAN MTU it is mentioned that it is 1500. So 1500 I can written as 20 is the IP header and 1480 is the data that is allowed. And you can, this 1480 is exactly multiple of 8. So you can divide this packet having 4384, each of what 1480, and you can further approach this problem. Yeah, so if I write for the first fragment, okay, then the second fragment, then for the third fragment. So how you do the calculation? See, the first fragment, you can say the 20 out of this 4384, the first fragment of which is 1480 is allowed actually. So this what we are calculating is something that you can call it as the fragment bytes is the distribution. The bytes which are available in the packet, that is distributed, you can say. So below parallelly if you want, you can write the fragment okay, offset also. You can write, okay, by dividing with 8 na. So 1480 if you divide by 8, it is 1 8 and 40 means what, 185 you can say. So this is how you have distributed, and if you go for the second fragment, it is 20. Already 4384 1480 bytes already given to first fragment, 1480 you are going to give for second fragment, and for the third fragment how will be given. So you can see 4384 minus, so 2 into, because already to the two fragments you have distributed na, so it is 14 okay 80. This is nothing but what, 60, it is 2960 you can say. If you subtract 2960 you will get the leftover bytes now, so it is 4, it is 2, okay, and it is 4 like this, 1424. So 1424 is allowed and that is given to the third fragment. Okay, for writing the code if you want to take a +4 as a multiple of 8, but okay, but with the help of total length and the header size you can easily calculate that value. Only 3 fragments are possible. So how does the destination knows that it is the last fragment? So MF value is 0. How does the destination knows that it is a mediating fragments? MF is 1. Here also MF value is what? 1. And you can see what they are asking now, you just observe the relevant fields in the header of the third IP fragment. See, the third IP fragment they are asking the relevant fields. So what is the MF value? It is 0. So this gives a clear idea. You can eliminate what you can eliminate, B and C you can eliminate, because MF is 0 is A and D also. Now what is the datagram length for the third fragment? You can see this value is 1444, okay, 1444. So there you can also okay eliminate what, D, but anyway we will go for the option A, because you see 1444. Offset how you will get? See, offset is very simple now, it is like this. Yeah, from the fragment bytes if you divide by 8, this is 185 means what? This is 0 to 184, and second fragment will start with what? 185. So 185 plus 184, because pattern it is going to follow, 5 plus 4 9, so it is 6, it is 3. So up to 369 is the second fragment. So third fragment will start with what? 370, so on like this. Now you see the offset for the third fragment is 370. Yes, all fields are satisfying. So A is the answer for this particular question. So please check your options. You can say A is the answer. Yes, Akash Chaudhary, correct, very good. A is the answer. Yes, Jimmy, correct, A is the answer. Good, very good. Okay, understand? Yes, everybody has solved the answer correctly. Good. Yeah, this is the slideshow, you can say it is 370, the same thing we have done. See, the basic idea, the internet has evolved from 1965 in and around, where the packet switching has become the reality from the ARPANET, where the actual message you divide into packets and these packets will be scattered in different paths. So from there the packet switching has been become popular. Before that 100 years back also circuit switching has prevailed, or we can say the telephone networks, basically the telephone networks, the basic principle, it is coming from the circuit switching actually. But from 1955 in and around onwards, the packet switching has become reality, and now we know the power of entire internet, how it is working on the packet switching. So based on that, this problem is given. You can try this question. Okay. See here they are just mentioning that it is a store and forward packet switching network given below. Assume that the bandwidth of each link is a 10 power 6 bytes per second, the bandwidth of the link. A user on host A sends a file of size 10 power 3 bytes to host B through routers R1 and R2, means the computer A is transmitting to computer B via R1 and what? R2 in 3 different ways. In the first case, a single packet containing the complete file is transmitted from A to B. In the second case, the file is split into 10 equal parts, and in the third case, the file is split into 20 equal parts. So the basic idea, it is just to, they want to convey how a complete message can divide into 10 parts and you transmit what is going to happen, how a complete file as it is transmitted, what is going to happen. If a complete file is divided into 20 equal parts, what is going to happen in terms of the times, because ultimately the efficiency or the utilization will be based on the whichever going to occupy lesser amount of time, that is a better na. So they want to test that value using this particular problem, you can say, particular problem. Now you see they are given all these values. So since time is little running, so I am just giving all the values. See the first case. So you can observe that the 1000 bytes you are transmitting, where 100 bytes is the header. So that is the transmission time. Given bandwidth is 10 power 6 bytes per second. So the transmission time will be 1.1 milliseconds, you can say. And why you multiplied by 3? Because there are 3 hops will be there na. See for this particular problem, why you got this 3 hops, you can see when there is a the source is connecting to router R1 or this particular router R2 and then connected to the destination. You can observe that it is a first hop, it is a second hop, it is a third hop, you can say, like this we can observe. So that is what here you can, that's why they have multiplied by 3. So the total time will be 3.3 milliseconds for the first case where the complete file is transmitted. But here why only transmission time? Propagation time and processing delays and queuing delays are negligible, because that is they have mentioned in the question itself. You can say consider only the transmission time and ignore processing, queuing and propagation delays that they have mentioned, and assume that there are no errors during transmission. See, if there are no errors, what is the need of applying the reliability ARQ protocols? You do not require the ARQ protocols for retransmission of that particular file or the packets actually. That is the reason. So anyway, that is the first part, and this 100 bytes is the header which you are adding so that they can be analyzed by the routers. If you go for the second case where there is 1000 bytes of the packet which you divide into which you divide into 10 equal parts, then each part will be 100 na. So that's why it is 100. Then why this one more 100? This one more 100 is the header which is given in the problem. And if you divide by the bandwidth of the link, you got 0.2 milliseconds for transmitting one single first part, 0.2. But if you observe this side, then what is the transmission time of 10 parts? Because that complete file is given 10 parts na. Each part is 0.2. If you divide in 10 parts, 0.2 into 10, it is 2 milliseconds is the total time it is taken for that particular source actually. Then what is the total time? This is 2 plus 0.2 plus 0. Why is 0.2 plus 0.2? Here this is the answer for this one. See, basically here when you are sending the 10th packet which is occupied 2 milliseconds, at that time 9th packet is here, at that time 8th packet is here. So basically in the next 2 hops, like next 0.2, next 0.2, this 10th packet will reach here. So for the 10th packet it is occupying 12, 0.2, 0.2, you are going to get this value. You can see 10 into 0.2 is 2, not 12, 2. So then this value is almost 2.4 milliseconds you got. So this gives one important message, we can say, instead of sending a complete message, if you divide into packets and you transmit, it is occupying the lesser amount of time that we can get from this particular question. But it is not always the case, but one case you got. Now you see in the third case where the file is divided into 20 equal parts. When 1000 bytes you divide in 20 equal parts, each part will be 15. So 50 plus header is 100 bytes. So it is 150 by 10 power 6. For sending each part is 0.15. So 0.15 into why 20? Because you divide in 20 equal parts. So 20 into 0.15 is 3 milliseconds. In the next 2 hops, when the 20th packet is here, you can see the same diagram. When the 20th packet is here, 19th packet and 18th packet will be there. In the next 0.0.5, this packet will reach the destination. So that is why you are adding this 0.5, 0. So here you got 3.3. What your observation here in the first case and in the third case, the value is same. You can see 3.3 and here you see here also 3.3 you got. So we can say T1 is equal to what? T3. T1 equal to what? T3. And you can also understand this T2 is smaller than the remaining 2. So from this you can tell what is the answer, you can see. So T1 is equal to T3 is there and T3 is greater than T2. So we can say what is the answer here? D is the answer for this problem. The basic idea of this problem is to convey the importance of the packet switching in the internet and the message divided into the parts actually. Okay? Yes, Jimmy, correct. Correct. Yes. The same problem, one more model is given. So please try this question also. So they have given this question. It is also regarding the packet switching only. See, the source computer is transmitting a file of size 10 power 6 bits to a destination over a network of 2 routers, means S is connected to the destination D. In between R1 and R2 are there. Okay, there are 3 links. So they have given the length and velocity is also given, bandwidth is also given. Now you see the file is broken down into 1000 packets, which comes under the packet switching actually, packet switching. So if you calculate the time taken for each individual packet, so after that for 1000 packets if you calculate, when the source is transmitting the 1000th packet, at that time only at R1 you are sending the 999th packet, and in 998th packet will be at that time. In the next 2 hops, the 1000th packet is going to reach the destination, you can say. So based on that, okay, if you do the calculation, you see you divide into 1000 parts. Now the file size actually 10 power, okay, you can observe the question, the file size 10 power 6. If you divide into 1000 parts, now each part will be only 1000 bits, you can say. So see 1000 bits by the given bandwidth, if you calculate 1 milliseconds, okay, understand. And the propagation time, they are given the length and velocity also, because they are given to calculate, that is 1 millisecond. So you can solve the same problem in 2 ways also. You see now transmission, propagation, transmission, propagation, transmission, propagation. So here 1 and 1. So 1, 1, 1, 1, 1, 1. In 6 milliseconds, first packet is reaching here, and it is synchronous pipelining it is following. So you can see time taken for the second packet reaching the destination 6 plus 1. Why 6 plus 1? Because when the first packet is reached here in the 6th millisecond, at the same time second packet is here. So second packet will reach in next 1 millisecond here. So 6 plus 1. So you tell me, for the 1000th packet to reach here, it will be 6 plus 999, because for a second packet when you add 1, then for the 1000th packet you will add 999 to the first packet. So what is the answer? 1005 is the answer for this particular question, you can say. Okay, so this is available. What is the answer? A is the answer for this particular question. So this is to tell an idea that what is the need of the packet switching, why the packets will be traveling, okay, the different paths, and why it will take lesser amount of time, and why the internet has become following this what you can say packet switching actually. Okay, so remaining all questions are also related to the packet switching. I hope you enjoyed the the session of learning the different model questions of regarding the flow control, error control, the MAC clear questions, the Poisson distribution involvement in it, how to access that channel, okay, how different subnets, how they are asking related to the packet switching question and the fragmentation question. Okay. Thank you for all. So almost all the important model questions we have covered. So further doubts are also there. Any question you can, or any topic you can ask me. Okay. Thank you very much.